Hello everyone, welcome into another live stream. And I'll be honest, I may have spent some time working on the video, you know, just a bit, just a tad. And I kind of sort of, like, it's a shorter video, you know, so it's just gonna be experimental mechanics. I kind of sort of, you know, a little bit finished half of it. So today I'm gonna try to finish the other half. This is the last video. Hi the by the way, hi the lemon, how is he? Hi. The last video was 2 days ago, and I'm already almost finished with the next one. So that's cool. That's good. That's good stuff. Good stuff, certainly. Alrighty then. Let's get to it. I don't know why, but I'm having a little fun just walking right now. Also, the coffee is delicious. Electron break is where we're at. What's happening yesterday? I just had a mental breakdown. I just, you know. You got pinked while sleeping. Why'd you get pinked? That was me. In the flow state. I really am. I've achieved Zen, basically. I've discovered the power of gambling. And it's a good motivator. Oh, I think for Minecraft. Oh. You reach Nirvana. I don't know. Well, I reached the state of Supreme Make It. At the very least. We can also play some music, I suppose. Just to, you know, get ourselves into the vibe of productivity music. There we go. Open with VLC Media Player. Shush, VLC Media Player. Shush. And let's do this, 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 let's do this. And a random error sound because of course. There we are. Around fell asleep in the middle of afternoon, slept 6 hours, I just woke up 10 minutes ago. Perfection. Kind of same here actually. Yesterday I've been on such a productivity roll in the past couple of days.
Were to leave the metal, it would become positively charged.
Hold on. Side quick on mechanics, introduction frames. I also just ate before the stream, which means I will probably be able to stream for a longer time.
Attracting it back.
There we are. How is that the last frame? Oh, we need one more frame. We're just straight up missing a frame. So salty right now. What happened? I've been grinding whole evening for a new set of scores. First one falls in lava. Oh no. If you want, I can give you the netherite star because it is kind of yours. I just you basically did 99% of the work and then gave me the star. So it should be still my nether chest. Ender chest, I mean, I think. Hide lemon. Even though I just got a second one. Hell yeah. This video is looking to be pretty solid, I would say. I like it. I like it a lot. It is short. It's kind of funny. There's some funny bits, but mostly it should just explain the experiments for the next one. Oh yeah, and this today I'm planning on finishing this one and also scripting the next one of the series, and also hopefully if Theft Tower to join in, then just work on the open muscle one. There we go. Frames, elec break, and let's call it 1310. That's 13,000.
If another electron charge, attracting it back. If another electron were to enter it,
And right here, this might be a bit longer. And this is going to be 30 frames. We do want this to go quicker and quicker, so let's see how it would look on 16 samples. How bad is it? Because there is a lot of volume, a lot of... Not too awful. I was expecting way worse. So what we're gonna do is we're gonna switch it down to 16 samples to make it go a little bit quicker. And also metaball. Fudge. And that's one thing I always forget about this texture is very much dependent on... Shucks. This texture is very much dependent on... Would that help? If I do metaball like this, it doesn't. If I do this, however, just set a parameter, then it moving in and out doesn't matter. That's a maybe, okay. We're going to have to transition to this. Say hello to me, or do you forget for neighborhood mental math asylum partner resident student? I did say it, didn't I? I know I said hello in my head. I hope it translated to me actually saying hello. I think I did. I'm so math brained right now. I thought don't worry was the exterior derivative of W. Okay. We might as well lower this right away actually to 16. And then right here have this enter the thing. Right here will start entering, so right here we're just going to change this yellowish thing from yellowish to red. Wait, no, blue. 0.5. Yes, to blue. And right here keyframe, and then this one to 60, because it's going to get pushed right away. Alright, sweet. Render away. Now, Office lectures. Oh, that's so cool. Oh, that's so cool when someone oh, that's really cool. Remember to switch to live chat. Okay, thank you for reminding me. I now switched. There we go. So, I'm waiting for the coffee to kick in. I did wake up like 2 hours ago, or an hour ago. this coffee is bloody delicious. Let's go over the side job after my internship is ended. I really don't know what to do. Wait, what? Wait, you got offered the side job after the internship is ended. Isn't that a good thing? That sounds like a good thing. Hi, the farmer main. Hey, I've just heard in your last video that you live in Poland. Do you also speak Polish? I swear, I'm never... I am never fucking ever mentioning that in any of my videos again. Absolutely never. You all can't behave. I am never mentioning that ever again. And people wonder why I say I'm from Eastern Europe and that's it. That's the reason. It doesn't make it like black coffee. I don't... I mean, I don't. But I did drink it from time to time. I prefer cheap coffee. That's what I prefer. Kashubian. Where's the stereotype of all Poles being fanboys? I don't think it's Poles. I think it's just Eastern European countries. So either Eastern European countries or Nordic countries as well. There's a stereotype. I think it's just to counter, like, you know, I think it's just an ironic take on, like an ironic spin on the hyper-masculinity. So, you know, when you have Slavs, then again, because of masculine or Nordic, and like an ironic spin on it by throwing in femboys, and with the conservative views. I think so. I think that's the joke, though. Hi, tune in next week for another episode of Make It Explaining Jokes. That would be my guess. Okay, now the coffee's kicking in. I can feel it in my bones, alright.
Enter it, it will become negatively charged, pushing it away. So you can imagine it like it will become negatively charged.
Alright, here, let's cut this. This is a ridiculous space, right?
Negatively charged, pushing it away. So you can imagine it like a magnet that's attached to a metal. It will always be attached unless
This is kind of dumb.
you give it some energy to pull it away. So if we have our magnet attached, if we hit it with a ball, this ball will knock it off. And the same thing happens for our electrode.
Okay, so right here's what we need. You're missing Timon. Timon's in chat, just not on voice chat. Timon is scared. Can you replace Timon? No. No. I don't make the rules, farmer man. I'm sorry. Now what we'll need is like a... How am I gonna do it actually? I could just do it with these. Huh.
Negatively charged, pushing it away. So become negatively charged.
Oh yeah, right, I forgot I changed it up. That's great. Okay, add frame hold. We need this to be right here.
If another electron were to enter it, it will become negatively charged, pushing it away.
As much as I like the metaballs thing, the texture is really awful. Count Remco's gravity and delusions out of him. I tried! Remco's too drunk!
Way. So you can imagine it like a magnet.
Ultimate power of Remco.
Pushing it away. So you can imagine it like a...
Okay, so we can imagine like a magnet that's attached to something and it's basically... Well, it's attached to it and then don't want to leave, but we're making it leave. Yes. So So what we need is we need like a magnet. Gay time and yay. Muscle memory. Okay. Let's do it as magnet red and let's do it as magnet blue. That's N. That should be magnet blue. Alright, and magnet blue will be, you won't believe it, but it will be blue. .8, and actually, yeah, here we're gonna have our magnets, and our magnet is going to be rotated by 90 degrees. There's going to be right there. There we go. Let's do 10, because why not? Considering that could be an insult depending on how you look at it. Actually, yeah, fair point. You make everyone gay will be an insult half the time and a compliment half the time. Huh. That's you know, when Schrodinger's compliment, you make everyone gay. It's an insult and a compliment at the same time. I like it. Metal? Do we have the metal one? No, we don't. Okay, fine. I'll just make a metal.
That looks metal.
Hi there! Oh, it's been such a long time since I've seen you, Tefta. Hi, how you doing?
Good, how are you doing?
I am doing really well, in fact. Incredibly productive. I don't know what has happened to me, but I am incredibly productive. 2 days ago...
As long as it's not metal,
I mean
you're good.
Yeah, 2 days ago I have worked for, or 3 days ago, I've worked for 21 hours, just non-stop. Yesterday I have worked for almost 17 hours, so I am feeling incredibly productive. Which is good awesome. Because the open muscle video, I have not done anything for it because I was waiting for you to join in order to script the software and hardware. So, would you like to do it right now?
Yeah. Heck yeah. Yeah.
Hell down. Yeah, indeed. I can leave this video for later. Let me just...
I got my energy drink and I just got done with work for the day.
Oh, perfection. I'm not quite done. I just started with work for the day, so... There we go.
Yeah, it's probably like early for you.
I mean, it's midnight.
Yeah.
I woke up 12
It's
ago.
all relative.
Close enough, right? I have a strategic sleep schedule where basically I go so right now I switch to nighttime specifically for the streams that we can script the open muscle. Script the open muscle, script the video. Yeah. Let me just check. Group theory jokes make itself. Okay, so so far only the intro is there. The what is open source, that's the more boring chapter, because the more interesting is this one. So first a brief intro. Okay, so for the how it works, I think in this segment of the video, what it's supposed to do and the what it's supposed to do will be already explained in the what is and why is open source chapter. This one will explain also like what it's supposed to do, how it's supposed to do it, and or actually in a very light way how it's supposed to do it. Right here, this is about the specifics.
Okay.
And the how it was made chapter will be for the additional interesting stories and so on and so forth, the actual like history whilst making it. So this is in this case, there will be the brief chapter, which is like a brief idea behind how it works, technicality. Hardware, that will be the actual hardware, you know, the for example, how with the band when you have the sensors.
Because there's like 7 versions of bands.
I really want to
2.2 versions of the labeled machine.
I really want to mention one thing. I know it's a very brief in comparison to, because there will be a lot of things mentioned, but one thing which among other things, I want to mention is how, because it's pressure sensors basically, right? Yep. Yeah, so
it is.
One thing I want to mention is how different it is to think about something in a vacuum versus actually making it in real life. Because in a vacuum, pressure sensors seem easy, but in real life, you have to consider that gravity exists, for example, which is already an extremely major thing for pressure sensors. So hardware will be mostly about that, like the difference between in theory, it should be simple versus in practice, it's actually not simple. And for software,
not simple at all.
For software, I think it will mostly just be AI, simply because as much as I want to mention like the cool things about it, like the local host, how you have two programs which can run independently instead of having it. As much as I would like to mention that, it is kind of irrelevant to the project, and it would require it's something that only people who actually care about programming would appreciate.
Yeah. Well, it is using UDP packets, which there's an inherent benefit for UDP. That's why, like Netflix or any streaming platform, like right
UDP
now,
is
people are watching you.
That
UDP packets
can lose packets, right, and still function.
That's correct. Yeah.
Okay.
TCP is like the handshake
Lossless.
one, and then UDP is
because
pretty much just like one way. Yeah.
Yeah, so UDP is the one where if you're streaming a video, for example, you don't actually care if a single frame gets lost or something, because I mean, it won't matter in the grand scheme, but it's much faster than TCP, where TCP is for stuff like banking, I guess, extreme example, I suppose, but with banking, you don't want any packet to get lost.
Exactly.
And then there are also other kinds that absolutely no one ever cared about, because 99.999% is just TCP and UDP.
Well, I think, what is it? ICMP, that's still considered TCP. I think everything is considered one of the two, but
yeah, because the subcategories. But I think there were some. I just don't remember them because I've never seen them used.
I don't either.
Actually, among the videos I'm gonna make, there are 2 videos upcoming also about networking, where the first one will be just how packets work, and another one I want to buy a server. Actually,
you have to throw in a joke, like one whole chapter that's like people networking and not computer networking, and like give no warning at all.
Oh, that is tempting.
Just pretend like the audience is the one that got something wrong.
Or actually, or like the journey of a packet, where it starts with a normal packet, but then when the packet actually gets delivered, right, like the whole information gets delivered, I just keep going. Someone is actually then watching the website, and then they tell it to their coworkers and so on and so forth.
Oh yeah.
That's actually really tempting. Okay, so how it works. So for hardware, how would you say it would be? How do you think we should approach this? Yeah, how it works,
so walk me. So how it works? The bracelet's made of pressure sensors. Yeah.
Okay. So imagine. I think in this case, I was imagining like a 3D scene with the full model of everything, the label and the bracelet. And if you want to explain how it works, should we go with it chronologically, with how you changed it over time, or should we go logically, as in how the information, or both? We could do both, actually. So,
well, how the information, because like how supervised machine learning works is pretty straightforward. right?
Yeah.
So supervised machine learning is what we're doing here. So we are taking the output, we're measuring it, and we're applying that as a label to the data that we're trying to figure out, which is called feature data. So the bulk of what we're doing is we have two sets of data, feature data and label data. And then at the very end, we just take away the label data and we try to predict the label data with the new feature data. So yeah,
Yes,
because
it's standard.
you have the training segment, and then you have the machine. Yeah.
Okay.
So you have the data recording process, the machine learning training, which can be done after data is recorded, and then real-time predictions. That's how I would separate it in my head.
So that's logically okay. So here's my idea. We will do it this way. We'll start with hardware, the bracelet, and is the labeling. Okay, we'll start with the bracelet and a simple muscle movement. How the bracelet records that muscle movement, or actually how the sensors detect that kind of muscle movement. That would be the first thing. Bracelet. Then the next thing will be labeling, how it's labeled the actual finger movement. And then with the software, we'll do like a logical, where does the information go? So starting with the information of the muscle movement and finger movement at the same time, both of them meeting in the AI learning, where the AI gets corrected for everything that misses.
Yeah, and you actually have to filter it just like you're going to do. So you have to filter it in real time. Yeah, so you have to match up the packets from both devices or from each sensor. Because in this case, each sensor has its own subcomputer.
I didn't even think about that actually. Yeah, if you get that mismatched,
you have to see the same process that you have to use to process and filter the data for training. You have to do in real time to make it predict. So it's kind of interesting that you have to do that.
I feel like Make It has a huge backlog of video ideas. I have video ideas for the next 3 months, okay? It's a massive backlog, not a huge one. This one I was supposed to finish in January. I don't think I'm going to be able to finish in January because this will be a massive video. I don't know if I'm going to be able to do it in 2 weeks. So to say that it's a huge backlog of videos is a massive understatement. That's what I said at the beginning.
Cool is I might actually give you footage of me actually moving a robotic hand for the first time.
Yeah, because I just
you can post it on your channel before I do on mine.
I think it's so funny. I basically was so slow with the video that this is no longer a problem. Like I no longer will have to wait for that. That will just happen before I finish the video.
Yep. So then you can use exclusive footage that no one else has.
Did I download the model of the everything? I think I did.
Yes, you did.
But I'm gonna download it anyway because I don't remember where I put it.
And you had to train it, remember? Because you didn't have the same version of one of the libraries.
Yes,
but
I remember.
We fixed it by.
Okay.
And you see how organized I made that for you?
That is really organized. I am really impressed because I do know how annoying it is to organize things like these.
I just felt so bad, and I'm like, well, I can't do much because I don't know what you're gonna want to do. But so I was like, I just spent like 4 hours.
I know I feel bad because this is really well organized. This is like beyond what I would normally organize, to be honest.
Oh, good. Well, I'm just appreciative because I think if more people, they're starting to get some interest in this, we can really it can be something in a couple of years if more people work on it.
I think so too. I hope so. I mean, this is really cool. Okay.
Hi guys.
Hi, the Timon. Hi, welcome.
I can't really see the chat because I'm walking to the store. So can you please read that to me if there's something interesting?
I will. Yeah, everyone is just saying that it's yay because you finally joined in and it's finally not just a Make It stream. Everyone finds unbearable just the Make It streams.
Yeah, I'm sad to disappoint the chat, but I know nothing about programming, so I'll probably just sit here in silence.
I mean, this isn't even about a program. I don't think. Well, the whole point of the video will be that you don't need to know anything about programming. Or, well, among other points, one point of the video is that you don't need to know anything about programming or engineering to do open source. If you're trying to land a job in the tech sector, then you probably need not only some experience, but also like you need experience, some formal education, and so on. But to do open source, you don't, and that's the beauty of it. You can just start any day you want. And
Let
so
me
I'll just try to
rephrase
explain it.
thanks to my amazing university, I have PTSD related to any computer related stuff.
Wait, Tefta, did you make this ESP?
So that one, I don't think so. I think that one I
Oh, I see.
imported actually.
Okay, that makes because it is really detailed. Yeah,
Well,
because
and I could actually have that green PCB have the actual traces, but I kept on getting an error from the cutout. So I'm like, well, you don't actually need the real traces of the PCB.
I could try to get that for you if you want. You see, I
You
am.
know, it's a KiCad export error. It's supposed to be export in FBX, but I have to remake the outline because it's like the CSV outline of the PCB has a break in it. I spent way too long working on it. I might actually try again.
I mean, at the end of the day, it doesn't matter. You can just, I don't know, make it green and it looks fine. But
Yeah.
actually, no, wait, not green. It's pinkish there. Okay, so if I do remember correctly, it is the two of these is a cell, which is a battery
Yes.
and logic. And geez, this is actually. I have so many questions now because that's the thing, as I mentioned, you don't know whether it will be a problem until you actually start making it. And in this case, only now that I actually start thinking more and more about how it's actually done, the more impressed I get with every passing moment. Because you do need the labeling device to be synchronized to the
Yeah.
hardware one. However,
Yep.
this is basically 4 separate devices.
It is 4
Where-
separate devices.
where
that's
3
correct.
of them
3
are
on the bracelet.
okay. Oh, this is good. This is good. This is really good. We're going to do it this way. Not bracelet labeling. Normally I know it may seem chaotic the way I'm going about this, but normally this is the process of the video making that I usually just do myself off stream, which is just
Yeah.
thinking about how to do a video. So I am going to delete
I
a
trust
whole
you.
bunch of ideas. You shouldn't. But here's my
Your
idea.
video, I trust you.
Here's my idea. I will do a fake hardware explanation, which will be just a very simple overview of how it works, which will be like really short, something like 2 minutes, maybe 3 minutes of just explaining how hardware works, just showing it as easy problem with obvious solutions, something that, and just pickle. It would take only 2 days to make, and then once I'm finished with that explanation, I will mention all of these things which you wouldn't think about as a problem, but turned out they are a massive problem with no workaround. So, for example, the gravity example isn't even the best one. The best one is synchronizing them right now. So it's going to be hardware, simple. It's going to be AI, simple. And then it's going to be all of it complex. So hardware simple, it's going to be trivial. I think I could do it on my own because that's just, it's going to be an oversimplification of how the bracelet works. That's easy. For all of it, then we're gonna stop and be like, but hold on for a moment. And right here, list all of the problems. And first one, the most interesting in my opinion, synchronization.
Yep.
How in my name have you synchronized all of this?
Yeah, so well the first thing is like for the sensors, I have to index the sensors. So the first thing that you do when you have a new band that hasn't recorded data is you have to press each sensor and make sure that it's in the correct order and give it an index. So you go through all the sensors and you press them one at a time.
Sensor, that's the entire thing, right? It's not 2 sensors.
Yeah, and so it.
Okay, so 0 to 5.
No, yeah. Yeah, so there's 12 sensors, so 0 through 11.
Ah, that's
Yeah.
precisely what I was asking for. Okay, so 0, 1,
But
2,
I do
3, this kind of thing.
but I do break it up between each group, right? Because each group is its own computer. So
Okay,
one
so we
computer
have...
is shared amongst 2 cells. So yeah, I do it how you were describing. And then if you look at the code for the cell, it has an index placeholder, and that's part of the code. So each of these computers has a save file mechanism. So once it runs and is calibrated, it saves its own file that has its config information on it.
I am so glad
And I'm
to be working on this with you, because normally this is the point at which I would give up. Going through documentation of something like this would take so much more time than just asking someone who just literally made it. It's mad. By the way, Stamp, you joined in, and okay. So for everyone who's wondering what this is about, because I suppose I should explain. I did explain in the past what this video was, but for the stream, this is This is called Open Muscle, I suppose, general enough. And this is Tefta's project. Tefta, who's on the channel right now. That's Tefta, yeah. Which is basically open source. It's open source thing. My goodness, my vocabulary just died the second I started talking. Open source thing for prosthetics, where basically you can record your finger movements based on your muscle movements in your arm, so that if you lose your hand, then you will still be able to get a prosthetic device, like a prosthetic hand, and based on those muscles, you will be able to move the fingers of the prosthetic arm. So basically, you put this on your arm, you use it, right here you put all of your 5 fingers, I'm guessing 5, I don't know, I don't remember last time I counted, but I trust that Tefta did the research and there are 5 fingers. And basically...
I have to count again, it's been a while.
Close enough. And so basically, right here, you put this on your arm, and you match the finger movements to the movements of the muscles in your arm. So you lose the hand, you still have your arm, and therefore the information is still there. And what I want to do is I want to make a video about this. So a video about how this works exactly, the story behind it, and so on and so forth. And the biggest part of it, the coolest part at least, and I wouldn't call it the biggest is certainly the design itself, but the coolest part of all of this is the fact that it is open source, which basically means that Tefta is just doing that as a, like, I don't know what to call it even, just as a side thing, you know. Just you know how it is. Sometimes you just wake up in the morning. As a hobby, exactly, yeah. Sometimes you just wake up in the morning, like, you know what, I really want to do something, and you just create open source hardware and software prosthetics, because, you know, just, because you can. And so that's what I want to make the video about, and so right now I am trying to understand exactly in depth how it works in order to make that video then. And that's what we're doing right now. So, Open Muscle software is...
the embedded folder.
There are 2 options, I pressed the wrong one. And right here, I'm guessing labeler is the label, and the sensor band is for the band. I am really clever.
So I think everything is in boot right now, if I'm not mistaken. I'm pretty sure it's all in boot.
In sensor band, in boot, there is...
Open muscle cell.
Okay, so open muscle cell.py. And right here, I'm guessing first run is the setup.
Yeah. And I think the settings, because it has a config file. Sweet, in the settings manager. Perfect.
All right.
So in this, I can't remember how I assign it. I was in the middle of writing the actual menu, because I put everything inside of the labeler to initiate like a config session. So that's where it would say like, open up the band on the table and press this sensor and do XYZ. But I don't think I did any of that. I think I just hard coded it. because you're like, oh, I'll be super ambitious, and it's like, nah, I'm gonna dial it back a bit.
Well, I mean, in my graphics engine, I still have a hard coded length of the file path to a DLL. So if you named your if you named your program something that's too long, it would just all crash. So I feel like this is pretty tame, I would say.
I do like how the computer's IP address is stored as PC IP instead of TCP. I don't know. For some reason, I found that funny.
Okay, so when you started, oh my god, this is gonna be tough. So you have two devices. Now, let's say that we have two devices, never turn them on, but everything is set up. Or rather, everything from a hardware and firmware sort of point of view is set up. We turn them on. Where does this all start? Because what I'm struggling with here is that...
Yeah, the first thing, if it's brand new hardware, you're going to have to index the sensors. So you're first going to have to configure the labeler. And you do that by just not pressing any of the pistons.
Wait,
then pressing all the pistons.
First,
and then for the bracelet,
labeler boot is what first runs.
Yeah, and I pretty much have everything going through the labeler, so that controls everything.
That's
it
really good.
Sends the information to the computer and to the bracelet.
Okay, so that already helps a lot. So you start the labeler, and the labeler boot is like the master boot, let's call it in this case.
Yeah.
Okay. So this is a great first start then, because I'm just gonna go down bits. So all the defaults that make sense so far. I won't go into it because I mean it's defaults right here. There are the config. Yep, that makes sense. Then start machine pin.
Yeah. So those are just the pins for the buttons on the labeler. So there's a start, select, up and down, and that's how you navigate through the menu.
Oh, I see. Makes sense. That does make sense. All right.
And I replaced the thumb with a joystick, so that's why you see the joystick thing there, because this is the newest version.
Okay. So so these are the 4 top buttons.
Yeah. So these are just separate buttons that are right by the screen that help you navigate the menu.
All right.
So these buttons are just to navigate the menu of the label device, because the label device controls everything else. So
this is simple enough. I feel like I will go through all of this code in the video. It's just that I'm not going to go through a Python perspective. I'll just use that code on the side as like the loading. So I will just be going down, and at this point I will just light up all the buttons on the labeler. So right here, when it gets to it, wait, are the buttons here?
Yep. You actually can't see them on that design, because that's an old design.
Oh,
I actually have the new one.
But it doesn't matter, because basically what I'm going to do is that when we get to these 4 lines of code, I'm just going to like give all of them emission so that they're going to light up as you go through them all. Just to, because I mean, in this case, that's what I like about this. Basically, this is the kind of code that for someone who doesn't actually code, it would be really difficult to understand what it does, because I mean, it looks terrifying. But what it actually does is simple. It just light up the buttons to set them up. And then right here, the joystick makes sense. Yeah. The LED is, I'm assuming that's just some LED to visualize that's walking.
Yep, it's the onboard LED that it blinks.
And
actually the biggest use for that is to delay the boot, actually. Because if you delay the boot by blinking an LED, you have more of a chance to interrupt the code before it goes into some kind of crazy loop and gets locked. So I actually use that as a debugging issue.
Oh my goodness, that's such a
delay.
That's such a hardware engineering moment when it comes to. Oh, it's always been so impressive to me with these kinds of ways to use something in multiple ways. It's the same as in when with designs of of CPUs, you have a certain register that does like 17 different things, and the reason why it does these 17 different things is because if you cram them all into register, there's like an additional safety thing through it. I always like these sort of hardware design fixes, which just kill 7 birds with 1 stone. These gosh dang, oh my goodness, these gosh dang programmers with their cryptic language. What does battery voltage pin mean?
That one I don't know.
Okay, the blink.
Sadly, that one doesn't work in the current version because of reasons. I won't go into it, but
I see. Okay, then the blink, which is just blink. Then you blink 7 times. Makes sense, to as you just mentioned. Then you define. I like how you define stuff and then use it right away, so I don't have to jump back and forth, up and down to figure out what things are. That's, I have to say, that's really pleasant. Init OLED, where you have all of these, and then try to get the try and accept. That's like, I can't get into the try and accept in the video because it's really, really boring if you know the programmer. But I mean, I just wanted to say that I appreciate that. I never learned how to use tries and accepts in Python.
And you could also do accept exception as E, and then print this was the error, and then letter E. So there's a way to actually print to standard output what specifically errored in a try except. So it can be amazing for debugging. But I haven't utilized that in here just because
it never fails.
I definitely know it's. Yeah, it never fails. It never fails to not fail.
Error checking is only useful if you're gonna have errors. That was my logic.
I don't have errors.
And then I always ended up with just memory leaks. Okay. This false, and then makes sense. You're setting them up to false because then when you set them up, you can actually check if it went right. If the I to C is still false at the end, that means it didn't set up correctly. So so wait, what is I to C?
I2C is a protocol. It's a single wire protocol. It has a data line and a clock line. Yeah, and so it's really neat because it can talk pretty fast, and it's just like a standard for electronics. It's for like lower speeds. Serial, you have every wire is its own data signal, so it's just super crazy with wires. So with only 4 wires, plus minus clock and data, you can communicate with a whole bunch of sensors. So I2C is for things that aren't that fast, like anything that isn't a microphone, and then I2S is used for like microphones and stuff like that.
I will make an Obsidian file for myself because I already realized that it will be a grand mistake to leave it for later, and I'm just going to make it right away to make like a flowchart of what is exactly happening. So open. Did I not create I might have not created a folder. That makes sense. Muscle. I just like the idea for the first time I actually will contribute to Open Muscle. This feels nice. Yeah. This feels good.
Sweet. Okay. So now I think I can have an updated board too while you're doing that.
Okay.
I'm actually exporting the new board.
There we go. And then there was the... Oh, wait. How do you do a chart? I already forgot how you do it. Into template, into new canvas. Is that the canvas? I think there's a canvas. Yes, that's a canvas. Okay, so first things first that's gonna happen is we start with the labeler boot.py. That's the first program that's being run basically. I really like these flowcharts in Obsidian. They're really nice.
Oh, I haven't checked them out. Let me see.
And we're gonna mark it as green for just program. Now, then we have a bunch of config BS, which will be yellow.
Well, that's how it saves. Yeah, it saves the info.
Yeah, I'm just the config BS. I won't get into it because I'm I don't think there's much for me to
So
mention there.
Well, it saves the file. That's what's cool about it. So the whole library is so that way it has persistent memory. Because otherwise, if you changed a configuration and you didn't load it this way, every time it turned on, it wouldn't remember what happened before.
So wait, it saves a file of what?
So yeah, let's say I calibrate the device while I'm wearing it, or I do something to the device. It will save it to a config file. It's like it saves state. So that's its persistent memory. So the reason why
Okay.
I'm loading things all wonky like that is so that way it's saved to a config file, and that if the device gets powered off and it doesn't know what's going on, it can just reload that config file and it will start up wherever it was last.
Okay. Now, next, if first run, so we're going to have if line 59, which is if first run, which we're gonna do as an if, which will be a blue. All right, blue like this. Then if it is the first run, it's saving the file, as you mentioned. No, wait.
Yes.
Okay, so if it is, then just save file and keep going. If it's not, then just keep
Prints
going.
loaded. Yeah, and that's just because the code is silly.
And just for code, we're going to do actually an if is going to be orange. There we are. Save file, and but that's only an if. If it's not, then we don't care, and we just keep going to what's next. Next, a bunch of config, and then 93 through 96. That's set up menu buttons. Am I call it that? Okay. That will be set up menu buttons. Hold on, right here. If it is a first, then it's green. If it's not, then it's red. I really like these charts, I do have to say. Oh, Thar just donated $20 to Prevent Cancer Foundation. Well, thank you so much, Thar.
That's awesome.
That is awesome. But what's even more awesome is that this is not like Thar's first donation. Thar has been constantly donating to charity and me. That's just like crazy. Look at it.
That's awesome.
It really is. $20 day 18. Thara now has 20% of the entire YouTube pie. I wasn't gonna do anything with it, that's why I wouldn't donate. Well, thank you so much for donating then. You are the second highest donator on YouTube. Make its only source of reliable income. Exactly, it's the Prevent Cancer Foundation, which is just a massive scheme for me to do tax fraud and basically launder money. I mean, money is going to prevent cancer, of course. It's not definitely into my account. Thank you so much, Star. Thank you. I'm so sorry for interrupting, but this was important.
Oh, heck yeah.
Oh, heck yeah, indeed.
And I have a quick question.
Yep.
You mentioned memory leaks several times, and what are those?
Basically, when you have an... you know how... Okay, there's a simple way I can explain it. You know how people really often complain about errors? You know, getting an error in your program?
Yeah.
Errors are actually phenomenal. As every programmer should love errors with all their heart. Because what's basically happening when you get an error is that something bad happened with your program and the compiler figured out what it was. So if an extremely simple one, it is going to be an extremely simple example, but if I go to Python, if I do print 100, it's going to work. If I do print 100, I do it in quotes like this, it's going to work. But if I only add one quote, it's going to break and I get an error. And Python is telling me exactly where that error is. That's why errors are great. However, especially in low-level programming languages, it may be the case that you fail the program in a way so that it won't notice. And that is because in low-level programming languages you have more freedom. So basically you have manual memory allocation. It sounds bad, but it's actually really simple. Manual means you're doing it yourself. Memory, that's just the RAM, random access memory, just memory of the computer. And allocation, you're allocating it.
C.
Yeah, like C.
And the point you talk about the pointers, right?
Yes, it can be. And so basically,
alright.
and so basically, a manual memory allocation means that you can deal with memory yourself. However, which has a lot of upsides. Basically, you have more control of your program. The downside is, though, you have more control of your program, so you can screw it up. And there are sometimes cases which, well, the most obvious way a memory leak can happen is if you're doing it yourself, you have to do everything yourself. So you can get yourself 4 bytes of data, like this. However, then what you can do, so if you get yourself 4 bytes of data, you can just write any numbers you wanted them. However, it is possible that if you allocate 4 bytes of data, you screw up and actually write 4 bytes of data into them. And then this additional byte of data is basically, you didn't allocate it, you didn't ask the operating system if you can have it. So it is possible that this byte of data actually belongs to another program. And I mean, operating systems have a safety for that, but so most of the time it will be just to your program. But what it basically means is that you have leaked the memory. You have leaked the memory outside of where it's supposed to be. And then you basically, instead of saving the value you want, you overwrite a random value, which is a pretty bad thing.
Yeah.
And so when it most of the time means that it just crashes instantly. But sometimes I was getting funky behavior where basically random colors would change. On average, it's a crash, because if you change a random value in your program, on average it will just straight up crash and die. But sometimes my colors were changing and so on and so forth. One really fun scenario, I know I'm going a bit too deep into it and I should just focus on this, but it's one of my favorite stories with memory leaks, is how I had a memory leak. I did not know what was causing it. So when I allocated like a single number, like I had a single number, like something like 1024, I had a single number, I figured out that the memory leak was happening here. So I just allocated myself 100 random bytes that I did nothing with them, simply because I knew that some random values would get just pasted in there. And I just allocated 100 bytes just for them to be screwed up. And it is the dumbest fix I have ever done in my career, but it worked, so.
Hey, if it works, it's not dumb.
In that case, it worked and was really dumb because I actually didn't know if it worked or if I just got lucky. Okay, so going back to this now, 98 to 101. This will be technically joystick, but I'll call it joystick/thumb, correct?
Yes.
Actually, 104. Was this S a W? Switch button.
Switch. Yeah, so there's a switch button for it. So if you press the thumb in, it's another.
So with the thumb, you right now not only with the thumb you're detecting all sorts of movement.
Yeah, well, I'm not sure what I'm doing because that's I would kind of leave the thumb out. It's still in the exploratory process.
That makes sense because I mean thumb has a much wider range of movements.
Yeah. So it's mostly just the 4 fingers that for sure works.
Okay, so 98 to 104, that's joystick/thumb setup. Then after that, there is the LED. Right here, which is line 107, which sets up the LED. And then battery level, that just sets up the, I'm guessing, I may be wrong here, but I'm guessing it sets up the battery level.
Yeah.
112. And this is, okay, this is in the labeler, that makes sense. Then there is the, after that, blink. 121. Blink 7 times. after the blink init OLED. So okay, so I2C is the protocol for sending data with a single wire, basically, right?
Yes.
All right. What is this? What is this? So OLED. What is that thing up exactly?
That is the screen. It's a 128 pixel by 32 pixel screen.
Okay.
So that way that you can see information displayed on it.
In this case, I'm going to just mention it as a screen in the simple explanation, and in the complex explanation, I will just add that as a list of things that you wouldn't think of, which is all of it complex will be first of all sync, second of all will be gravity, and third of all will be OLED with a single cable. Because I think people do not appreciate the standards that exist when it comes to cables, because setting up something to move information with a single wire is a massive pain. So 146 set up screen or OLED screen with a single wire using I2C. Now, bless me.
Yeah, and I2C is pretty cool. I like it a lot.
Oh, it is. I was I remember I was really worried when I was buying all my Raspberries that about sending data, but then I learned about the fact that the obvious fact that standards exist.
Yeah.
Mm,
It's super helpful.
it really is. It's incredible. In this case, I don't think there's anything especially interesting about the OLED. OLED rotate false, and I'm assuming these are all just to initialize the OLED, right?
That's correct. Yeah.
This to me seems like
they-
just a
you can rotate
function
it.
for the standard to a screen.
Yep. Nothing is crazy. The only crazy thing is the front function, which is that is something I'm very proud of. It
Wait,
is actually it's right below there.
the print?
Yeah, it's called Frint with an F.
Am I?
It's right below.
Print. Oh my goodness. Oh yeah, this one. Okay. Wait, what is print?
What that does, yeah, so what it does is it pretty much makes it so it's like a bash script. Or it's a REPL environment. So that way anything that's printed onto the screen gets superseded by something below it. Essentially, it's a command line output, right? And it also stores the last 20 things printed to the screen. So the screen, the frint function is a very, very streamlined code that will just show on the screen the last thing that was printed to it.
Okay, I like that. I'm gonna step right here.
And so I use a variable called RAM, and then I revert the list and blah blah. Do some fun stuff.
Right here, I'm gonna save the print on the side for when it's used, so that I can link it up.
And what's also interesting is that it's just for the OLED, and you can use it just like print. So it will keep printing whatever exists. If you send it like a dictionary that has a nested dictionaries, it will actually recursively open up the dictionary and print the smallest item, right? Just like print does, which is kind of fun. So I ended up actually redoing
You basically implemented a console.
Yeah, it's a console. But I actually extrapolated
really cool.
on this and made a standard redirect for the output, which you can't really do in MicroPython without recompiling it. I won't get into the nerdiness of it. I was bored one day.
I mean, to bring back binary coding, I don't know. As much as I like binary coding, for stuff like this, I don't think it's too required. I think binary coding is only when you need like speed. That's when it's useful. And this doesn't actually quite need speed. Init network, pretty self-explanatory, I would say. Read all. What is read all?
Yeah, so read all goes through the Hall sensors. So that's the main 4 pistons. So that's a very
Read
quick
sensors.
way of the ADCs. So that's the primary function of the labeler, which is to read the ADC values for those Hall sensors,
So it's reading
which
all
represent
sensors.
the 4 pistons. Hmm.
Okay. I just want to make sure I understand so far. All right. So we have this. Calibrate. I'm guessing. Oh, I can see the print everywhere. That's lovely. That's really lovely. I do have to say.
And if the screen isn't there, it actually just prints onto the console.
That is really
Right.
great. It is just print all the way down, I'm guessing.
Yeah. Once I start print, I just use it as my main.
Okay, calibrate. I'm gonna random dog a complete guess. It's to calibrate the sensors. You
That's
press and
correct.
you release,
Yeah,
you check.
they're min and max.
Okay. Calculate battery percentage. Well, that is certainly a massive mystery to what that function does. So I'm
Yeah, I
gonna use
forgot what
my
that does actually.
I'm gonna use my incredible detective powers. There we are. Now after calculate taskbar. Oh, that seems more curious. Is that for creation of a?
Ooh, the taskbar is awesome. So the taskbar has 4 rectangles that draw the pistons on the screen in real time. So you can see
So it's like a
when the
visualization.
pistons are depressed. It's a visualization
Oh,
of
that's
what's
cool.
going on to make sure the device works. Yeah, have you not seen a video of it? I don't think I've filmed it much.
Yeah, I mean, I haven't seen the label that much. I've only seen it used.
1 second.
Let's go back to typing millions of O's and yes, hell yeah. Oh, you mean binary coding like a manual bind? Yeah, that's a maybe. We need to bring back obscure
But still,
incantations of papyrus scrolls. Okay.
so where am I at? 1 second. So when this thing turns on, right? So
That's
those pistons.
so cool.
Oh, did it just power off? 1 second. Right when I want to demo it, those weren't moving. Oh, I need to charge it. But yeah, they do move. But
I think I could see one, I'm pretty certain. At least in the blink.
yeah. It's super low on batteries, so I'm gonna have to charge it. So you'll just have to trust me. But yeah, they move, and they move with the other guy.
That is really cool.
And it's also weird the fact that I have this sitting on my desk. Like, oh yeah, I made it. I have this exact thing.
I mean, to be
Near missing
honest,
it in 3D.
if I ever make something, I will have it sitting on my desk for as long as I can. Until my desk gets completely cluttered. That would be a sign of success if my desk gets completely cluttered in that case. I've returned. Welcome back, Da. Welcome. Okay, so taskbar is so is taskbar for creating or updating? It's updating, right?
Yeah, the taskbar.
Oh, with everything,
it just
calculate battery
updates.
percentage. Battery percentage. Okay, that makes sense. So, battery percentage gets in here. Read all sensors. I'm guessing will also be there.
Yeah, it might be fast read. I'm not sure.
It doesn't matter. The point is, it's just reading like this. Hold on. Read all. Read all is in the taskbar. Now calibrate. 180. What happens with the calibrate function? When's it used?
It's only used in the menu. You access it through the menu.
Oh, so if you want to calibrate, then you calibrate. That makes sense a lot.
Yeah. So you don't ever use it. It doesn't make you use it.
As much as I love the friend, I'm thinking I'm gonna leave the friend because the friend is, I would need to link it up to everything. Okay,
Yeah.
so that makes sense. And then actually, this resource census if you want to. So this would be an if, which I used orange for, if I'm not mistaken. So if you want to, you can calibrate, but regardless of calibration, it constantly reads census and battery percentage and does like so. Okay. Then after the taskbar, there is draw menu at the end. That makes sense. And then fast read, which I'm guessing is just fast read of read all.
Yeah, so in order to send this as fast as possible, I tried to optimize it. And so fast read came after me testing how to make this send data as fast as physically possible. And this was the result.
So this is just a read all 2.0.
Yeah, and it's a loop too, I believe. No, it's not. Never mind. Yeah. It's just the fastest. And that's where I used exception as E, print error.
Oh, I see. Error checking.
Yeah, and then EST, and then, yeah.
Unnecessary completely. You don't need to check for errors. There aren't any errors. ESP now sent, I am guessing that is, we're finally getting into the data movement between, right? So all of this.
Yeah.
I'm going to, there's like a way to group stuff. This, it is, sweet. Label. There we have it. And now, we enter the networking. So ESP now sent, I'm guessing that sends data.
So yeah, so ESP now is a protocol that you can just, if you know the MAC address of a device, you can directly communicate without a router. So this is only used to like control my other inventions. It's not used internally yet for like the open muscle.
I think
it's just there to control my LED.
Just casually, the coolest thing you could possibly say. All right.
Well, it is because I want to use the label device to control like my other robots. So I use that protocol.
Okay. Well, no, it's a menu, and right here is just the main, which I'm assuming puts it all in order and just generally makes it work with all these functions. So
that's the menu. The menu, yeah.
Yeah, main. Okay, so main menu, from which you select everything. Fast read loop. Oh, that's the loop one.
Yeah, the loop one. That one, I think it, does it call fast read? Yeah, it does. It calls fast read inside of it. But yeah, the menu I was very proud of too, because the menu is structured as such that you can add and remove items to it pretty easily. And I now use it for all.
That does look really clean, I have to say.
At the very top, there you go. That's how it stores. So you can see how it actually executes the items in the menu.
That is really, really clean.
Menu items. And you can have as many sub-menus as you want to, just based off of the structure. And it does debouncing, which that was actually the hardest part, was debouncing the buttons properly.
Wait, is loop misspelled here?
Oh, it probably is.
Oh, first thing it is misspelled. Pun I was missing. Okay, so network manager is that I already forgot the networking ones. Discover basic connectivity. Okay, no. So network manager is an import, which you just set up, and then you just do the main loop, and in that main loop you have the main menu. If it's in the makes sense. Okay.
Yeah.
Everything makes sense. You also print the first one. I love the print so much. And then but
yeah, those are just some debugging ones.
But I do have to say that
the main loop
is pi greater or equal than 10 is hilarious.
Yeah.
I just think it's really funny.
I don't know. So, do you ever do that? You just like write jokes for yourself?
I absolutely do. I love it.
Just to be stupid.
Oh my goodness! On the website, back when I was doing comments, the function responsible for adding them was called comment. Or
Oh, okay.
I absolutely love just calling things just dumb ways or puns most of the time. It is phenomenal.
Yeah.
It's little
Pi,
joys in life.
pi plus equals 1. You know? Pi equals 1. Pi equals -1.
Okay, so
Well, and the access point that I use, because this is visible on GitHub. The password is 314156. It's pi. It's 9 digits.
I
of pi.
see. I was thinking. I was trying to visualize it for a
31415926553.
second.
Yeah.
Okay, so then to finish it off, right here we have the main, which then goes to, which I'm gonna make a bit smaller. Main, which I'm just gonna visualize like this: main loop, main goes to main loop goes to main, and taskbar links to the main loop. And this is basically how the label works.
Yeah.
Okay,
In
this
a
is
nutshell.
solid so far. Now
And
for
the bracelet works the same way, except for a little bit more simple. It doesn't have a screen, so it doesn't have to initiate a screen, but it initiates the same exact code because it has to do the same thing by sending to an IP address. So the bracelet is, you could probably just duplicate. Yeah.
for some reason
weird.
duplicating it doesn't work. Oh, it does, never mind. So right here, bracelet. So initialized in the same way. So bracelet. Sensor bond, open muscle. Okay, so it starts with this. This time, I'm just gonna call it boot still because it starts with boot technically close enough. Sensor bond. Then we have a bunch of config BS. Then if it's the first run, it saves the file. If it doesn't, it just keeps going. Then right here, it's config. You initialize. You don't initialize menu buttons, obviously, that makes sense. You don't initialize the joystick
LED.
thumb. Init LED is right. Wait, is it Rondo?
Yeah, it's right there. Right underneath the joystick thumb on the right side.
Oh no, I mean when init LED. I'm just looking where. Okay, so init LED makes sense. Throw. Wait, what is throw?
Throw is just a function I wrote for it to make the LED blink, and I send it an amount.
Okay. Init network self-explanatory, calibrate self-explanatory, fast read self-explanatory, fast read loop self-explanatory, bracelet setup, which just prints bracelet setup. Well, that one is a must.
Yeah.
That one I have to include when. Okay, now right here, main loop, which is just the main loop, and there we are. So we have this one, and we start with 200. Set up LED. Then enumerate whole define range, and then temp ADC pin I, and then enumerate row 5 cell. Okay, and then we have the cells for this network manager. Then you set up networking. Yeah, so you set up. Wait, in this case, you already set up the, because HAL, that's the wait, 6. That sounds like the set of sensors.
Yeah. So the number of cells. Where are you at now?
Right here, this loop.
Oh. Oh, there's. Oh yeah, yeah. The only reason I have a range in 6, it's actually skipping some. It's getting those all, but then I only use certain ones of them. But yeah, those are the ADCs that it's reading. I don't know why I have them set to 6. There's a reason though.
I don't know why, but there's a reason though. It's certainly a mindset I can relate to. Adept to mechanics.
Well, yeah, because all of them are in a row and GPIOs, and so they're probably going to be used for other things. I don't know why I have them here.
So
But
set
you
up
can
pins.
also see that, yeah, they're just setup pins. The ADC pins, those are the analog to digital converter pins. So what turns the output of the Hall sensors into a digital number.
Then 2226 plus will be setup networking. And then that is it. Then you just go straight into the main loop.
Yeah.
You just said Hall sensors, and I got PTSD from a laboratory work in university.
I don't doubt it. I have PTSD just looking at all this code that I had to write.
I mean, I do have to say,
And
I am a
thinking of the
massive.
code I'm going to write in the future.
I mean, I do have to say, I'm a massive fan of a bracelet setup, which Prince bracelet setup. That is probably one of my favorite functions.
So remember I told you that I was going to work on it so that way you would initiate it and it would like tell you what to do.
Yeah.
That was that. And so the fact that it's probably going to be like 400 lines of code in the future, and the fact that right now it just says print bracelet set up, giving you a false sense of hope. Like, it must have done the thing. No. What's it doing behind the scenes? Oh.
So I really like it right now, and here's what we've got so far. Right here, we do not, in fact, have a taskbar though. We do have calibrate, I remember, but we do have read those sensors. Do we have a calculate battery percentage?
No, because it can't read. This version cannot read a battery level.
Okay, so it just reads sensors and you can calibrate them.
Yep.
All right, so these are the only things that happen here. And now I'm guessing that we need to, well, take this data, and have them come together. To
right now, over me. Dum boom boom dum.
I didn't get that reference. I don't listen to.
Yeah, Beatles.
I see.
You didn't get that reference?
No,
How
I listen to both. You don't get AJR references, okay? Timon, okay? Yeah, you don't even exactly. That's what I thought. See, I also know music.
not getting Beatles references is worse.
Okay, now, so the third thing. Wait, this is bracelet. Hold on, it just hit me. Is this a cell or a bracelet?
It's a cell.
Ah.
So there's 3 of those going on at the same time.
My instinct was right. Okay, so that's important.
Each bracelet.
Is it ever combined into a bracelet, or is it dealing with 3 separate cells?
It's dealing with the 3 separate sections, right?
Okay.
But the next version hopefully will just have 1 computer for the bracelet. But in order to get what I have right now, I had to have 3 separate ones.
I mean, I like this setup as well because, and I don't think
it's insane. No one should do it. I shouldn't have done it.
I don't know. It makes sense to me. It really does make sense to me because the thing is, it is symmetric. There is the threefold symmetry there, and to me it seems like
it's rotational symmetry.
Yeah, it makes it easier because you only have to walk on 1/3 of it, and then if that 1/3 walks, then you know the whole walks.
Sure.
It makes sense in my mind. I don't know. It makes sense in my mind. I guess
it makes it 3 times more complicated. 3 more things to go wrong. 3 separate. It actually makes it 3 times less efficient.
Yeah, but if you have like a debugging software, then you can add like 3 separate rectangles called squares, and if one of them fails, then you can have it flash in red, and it's gonna look really cool. So
Well,
you have to think
you
about
could
the
also have
upsides.
redundancy built in. Well, one of the cool things with I wanted to have redundancy, so even if one of the computers broke, it would still work, which is be kind of cool. But
that would be basically like Iron Man level of engineering with this kind of thing where because let's be real, I don't
backup
think
mode.
it would ever be needed to actually have this kind of redundancy. Because I mean,
Yeah.
if it breaks, you can just repair it. But at the same
Yeah.
time, it is something you should totally do because it will be the coolest thing. Where basically,
Well, check this out. That the bracelet, all of the cells use the same PCB. So technically, you can reroute and repurpose one of the cells to fix another
you
because of that.
can.
Yeah, and so what's funny is that yeah, I don't know. There
I
is
mean-
some stuff like that built in.
I
which is
mean,
kinda
you
cool.
could have it in a way so that all of them are connected. You just pick which ones they want to activate on. So
Yeah.
if you have 3 cells, you have all three PCBs working, then you're fine. But if you only have one, then you first do 1/3, then the other third, then the third. Like you just
Yeah.
reroute the thing, and that is actually there's a lot of potential for redundancy in this case. You are right. Okay, so
Yeah, and I am going to use it because I'm actually using I2C ADCs in the future. That's going to fix my wiring problem, but that's a topic for another day.
Okay, so we have the labeler with everything set up, the cell with everything set up. Now, what's the next step?
The computer. The computer is the receiving program that is going to record all of this
Where
because it's useless.
I'm assuming
That
it's
is
labeler.
inside of the. It's
PC.
actually
Makes
a
sense.
folder above.
It
PC.
just hit me
Yeah.
that the PC folder is there, and it's probably and yeah. Okay, I'm a bit slow. All right, more coffee.
Yeah.
So
And yeah, Open Muscle PC. I think that's the only one.
so now, right here we're going to have.
That is that? Yeah, that's good.
Now we're gonna have the third thing, which is PC. I can't align it properly. This is driving me mad. Oh, screw it. It's gonna be down here. There we go. Perfect. So PC and networking makes sense to link it all together. I'm going to skip over the networking setup because there's a lot. And then main setup networking, all of it. And okay. So in this case, we have the file, which is PC slash open muscle PC. Then a bunch of this time networking config BS. And I'm so sorry for calling it BS, by the way, but
No,
I don't.
don't bother me, man.
And then in this case, the next step.
Data visualization.
Oh, right.
Because you want to see on the screen to make sure that you're receiving the packets.
That does make sense. You would, I suppose I suppose you would want to check. Now that I think about it, it does make sense.
And in the video that you saw, it did actually glitch and stop showing it on the screen, but it didn't stop it from recording to the file.
Okay, so right here, this is the graphics visualization.
Yeah.
I'm guessing. There we go. So bunch of networking config BS and then visualization config. That's line 84 plus. There we are. And then right here, all of this. And I think we've reached the spot with devices of being set up. So right here.
Yeah, and this is just for there's a lot of PC programs, so this is just the one that records the training data.
So in this case, I'm
So
guessing.
this PC file is only recording the training data.
So I'm guessing 4 fingers, 12 centers.
Yes.
Okay.
Correct.
And then right here, plotting, and then just so this right here then is just reading and visualizing data, right?
Yeah.
And in this case,
It
it is
looks-
taking them from the main loop of both things.
And I just realized something, that you're using an outdated version of the GitHub. I
Uh-oh.
don't know how that's possible. Let's see.
Make it start reading chart. I am. I love how Maker's response to making a mistake is immediately downing more caffeine. I had a round of coffee, I already drank it all right now. I need to make more. I'm trying so hard to understand what is happening here, but like, what? PC sells bracelets WTF? Well, that's what these streams, that's the difference between streams and videos, you see. Right now you can't understand it because we're not really going over it. This is more like a data gathering portion than explaining portion. The video will be actual explainer. So in the video you'll understand it better. But I do like this this canvas because it is putting everything into pretty good perspective, I would say.
It looks cool. I like it.
I mean, it is extremely simple still. The simple segment I'll be able to script myself, but the problem segment, I will need you for it. So the next thing we're going to do is the problem segment. In the meantime, while you can follow it, actually, I will probably render for my own video.
I got it. So whenever you update it,
So
it
you can
should.
imagine
There's
like a
other
magnet
files
that's
like
a
train
star.
model and record data.
I'm sorry, could you repeat
It
that?
makes more sense. So the files are renamed for the PC software that I updated on the GitHub.
And what is the new one?
Yeah. So there's real-time predictions, record data, socket test, virtual sensor transmitter. Yep, those are the ones.
Wait, am I hold on,
Yeah,
where?
it should be in.
Because in PC I only have Open Muscle PC and Socket Test.
Really?
Yes.
I don't know why that is. A PC, you hit refresh. Hit refresh.
Am I in an old? How did I even enter? Wait, did I enter? Maybe I'm in an old thing. History. All the newest ones are from November.
Huh? I have no clue.
Am I in the right
Find it.
repo? Open Muscle software.
Let me find out.
What does that code do? Well, the code is mostly just to operate the hardware. The hardware is. If you want an extra explanation, the hardware would be better. That code is there basically to operate this. This right here.
Well, I'll get it someday.
All right, but why does the old version matter? What's different? What is there anything, any major differences? Because I mean, this is just here for me to later on, you know, make the simple explanation. So for the For the complex one, we don't actually have to. Is this good enough to like explain how it works? Where it reads and
Yes, it
visualizes, and
is.
then I can just plug in right here AI, basically.
Yeah.
Because
So, but there's separate programs for the PC. One is to record the data, and that's what it's going to do. What you have listed there. Then you'd have a separate program to train the AI, and then a separate program to do the real-time prediction.
I mean, yeah, that makes sense certainly. But in this case though, I will only focus on the training, and then from that training there will be the finished AI, and then finished AI will be, and that'll be like the finished the product of OpenMaster in that case. Hi there, Mark. Welcome. Now this is the simple one, the simple explanation of how it works, which will be simple. Now it is time to get into the problematic details. So first of all, how do you sync it all?
Yeah. So the solution that I use now is actually to have them all send a packet a certain number of times per second. And so that way I can guarantee within a given second there's going to be so many of each packets. So I just use the timestamp of each one to combine the closest ones.
But when you start the labeler and the bracelet, they both. How do you ensure that they both start at the same time? Actually, no, wait. The packets come over. I'm an idiot.
Yeah. So it's a constant stream. So since all of the packets are just being sent to one address, they just get combined with the closest timestamp. You don't actually have to have it be more complex.
Never mind then. That was
And
actually
each. But the index of the sensors is important because you have to know which sensor is which.
What other problems are there that seem really simple on paper, but in reality turned out to be really rough?
Well, yeah. So it is rough if you mess up the way that you do the algorithm for making all the packets get as close together as possible, right? Because there's a delay in everything. So if you match up the sensors incorrectly, like the syncing is an issue, but it's actually kind of simple to solve.
Okay, so
syncing is a big one. The second one is how fast it's reading the sensors. You need the fastest, the more data points. That's based off of the frequency that you're looking at.
How quickly are you reading it, by the way? Just like per second.
So right now, in this example, it's 25 samples per second, but I can go up towards 100.
That's not bad.
So yeah, so it actually works better the closer to 100 that you get, but it also is really laggy on the computer because you have to do all those predictions in real time. But yeah, so this code right now is set hard coded at 25 samples per second.
Oh, I think I have one good problem. One thing which could be a good problem. It is simple. It's very general, but just the fact that it's general, I feel like could add to it. Unless you have something better, because I mean, right here
the noise. Yeah. No. Yeah. What's your idea?
My idea was just the absolutely obvious fact when you think about it that the battery is going to decharge, and that you have to check for it. You have to check for it decharging. You can't just plug in the battery.
Luckily, you kind of can with these ESP32s because there's a reference voltage internally routed, and it does those checks. And that's how the ADCs know that
if
their
one
accuracy
cell
is
going to, if one cell dies, then you will have incomplete data. Basically, that's what I meant.
Yeah. Oh yeah, true. And you can't have incomplete data. So like this version of machine learning model we're using does not like to have blank spots. It just breaks it. You can't have any zero value. The AI will get mad at you and break if you fail to give it a value when it expects one.
Is those 5 enough? Or is there any
I think
other?
so. Packet alignment, noise, gravity. Gravity is insane, right? The
It
fact
really
that
is.
each of the cells is the same. So if you modify one of the cells, it modifies all 6 of them, which also modifies the entire weight of all 6 of them, which then changes. Yeah, so the springs and the gravity is the crazy one.
Gravity is my favorite one because I mean, it's such a difficult thing to solve. Because I mean,
Yeah.
it's a huge. Like, your AI has to generalize really well in order for gravity to not matter. Insanely well.
Yeah. Well, that and the fact that the pressure sensors work mechanically because I'm changing the surface area of the feet, right? So gravity is the springs in the sensors have to go against gravity in order to make sure that they don't depress. But they need to be weak enough that the muscles can actually depress
They need to be
the
stronger than
pistons,
gravity,
right?
weaker than muscles.
Weaker than muscles, yeah. And so that can be done. And I can't find the perfect spring. That's impossible. But you can actually change the surface area of the feet to make the spring act differently because you're actually, absorbing more energy
How many
by increasing the
designs
surface
were
area.
there for to solve the gravity problem?
Well, that was a lot. That was about the first year. The
Because
first year was trying to figure that
I
out.
really kind of want to do here like a manic edit
I have
of just
no, I
really quickly listing all the different every single time you've changed something, just listing it.
well, in one of my videos, I go through the prototypes, which is crazy. I can't remember which one it was. I'm gonna find it real quick. But I actually just go through the history of it. And I don't think it was this one. And because I have a big bin of all of the prototypes. And it was just I was like, holy crap, that was a process.
Make it sometime before you said you love naming things in dumb ways. Have you ever heard of Java? Yes, I have heard of Java once or twice.
Java.
The forgotten language. But no one codes it
Oh,
nowadays.
here it is.
Hold on.
So this video goes over the stupid stuff. He's doing in chat.
Today
Oh, I
wanted
already
to-
have it liked. I already have the video liked.
update you on progress
Yeah,
that's
at
being
2 minutes
made
and
for
15
open muscle.
seconds is where I go, where I start. 2 minutes and 15 seconds in.
Back and forth. I was working on a
And that's the
4x4
first
matrix.
one.
I had to reduce
That's
it
on my
to
wrist.
2x2. This
That
was with
giant
a
green
spring
block.
piston mechanism that I made. It was very cumbersome, but it was a proof of concept. And when I flexed,
So
my
yeah, it
fingers,
started with
these
just
pistons actually
4x4,
compressed
and then those are the sensors.
away from
Oh,
the Hall of
crap.
Fame sensors. So that was the first.
That's my first
indication that I
prototype.
was on the right path to creating something that would work.
And you can hear it clicking
I
in the
then tried to
video.
make an entire bracelet, with a single.
I remember how excited you were
sensor
about the
and 4 of
click.
them. That was where I got my
Yeah.
feet wet, so to speak, into the project, and I realized.
So there's a lot of
complexity
versions.
and
So
wiring,
what I go through in this
was kind
video
of a mess,
is
but I
like an
eventually got
overview.
to open
So I
muscle
had
12.
4x4 array. I was super ambitious. And then I was like, no, I'm going to have a 2x2 array. And then I was like, nah, that's too complicated. Now I'm going to make a 1x1 array. That's what this is. And then I did a 2x1 array. And that's what actually ended up working. Then I made the label device. And then I've made 2 more arrays of 2x1.
So I had one set of recording. I left the bracelet.
It's a
on
process.
Oh, I see the four lask and band ones. That's the visualization.
forearm.
I can imagine it's a massive thing. It really is.
Kind of crazy.
Really, it really is kind of crazy. Okay.
Yep.
This is great stuff. For the gravity one, could you, in your spare time, just give me like a list of every single change you have made? Honestly, the more the better, because in the gravity, I really okay.
Yes. I mean, I should have a file here that I like categorize stuff as close as possible.
I mean, it doesn't need to be perfect because it will be just for the joke of the video that's meant to, just accent the fact that that something that you wouldn't even think of does end up just taking a massive amount of time a year because it's the actual problem. What's wrong with Java?
Yeah.
No one uses Java. They use Kotlin. But okay, so this is hardware simple I can do, software simple I can do, packet alignment to sync I can do because in this case it's not really a tough problem to solve. It's like more something you need to think of. When it comes
Here,
to
I uploaded a file into our voice chat. That is a Word document of the updates that I've made. And it doesn't want to move, so I'm just going to copy and paste it. There we go.
oh, I see. Okay.
So that's like as much as I've kept track of the changes.
That's a fair bit of changes.
Yeah. And the naming conventions are all stupid. It's like I didn't know what I was doing. But yeah.
Oh, then in 2023, it just hit me. It just hit me as 2025. That. Wait, is 2024 not here then?
No, it's not. Not much happened in 2024. I just kind of made the newest version. And my videos kind of describe that.
Okay.
It's a lot. Don't save. There we go.
I'm thinking about
Oh,
now.
but then I do have.
This is an advanced stream for smart people. I don't know. I mean, advanced maybe like in depth, but I'm surviving so far. The smart people might be relative. My word just died. That's word plan, I guess. It just cannot open the file. Struggling.
You hear that, chat? Like, make it self-taught quantum mechanics to themselves and
Quantum mechanics
just
is not
refuses to
difficult.
call themselves. Quantum mechanics is not difficult. Okay. Yeah, okay, sure.
What?
You self-teach yourself quantum mechanics and you refuse to call yourself smart. It's just painful to watch.
We need
Watching
documentation
me
for the
cry.
stream. That's why I said smart, handsome people. Well, I mean, we have seen Theft on stream, so I will agree with you there. Oh, there we go, it opened.
Oh yeah. So
Tissue
I call
deformation
this
myography.
pressure myography. Yeah, I was trying to figure out what to use it because people use EMG sensors, MMG sensors, but what I'm doing is something different. So I tried to talk about how this would technically be a type of myography, which is a muscle sensing, but I like to call it tissue deformation myography or pressure myography.
I mean, it makes sense.
Yeah,
In
because
this
there
case,
needs
I
to be
can
a name
see
for it.
I
'cause
can
it's
see
not.
arguments for both sides. Like on one side, electrical activity would be more efficient just because of neurons, but on the other side, this electrical activity is guiding muscles. So in this way,
Yeah.
you're basically filtering out the noise, but by adding noise, you're sacrificing the noise of unnecessary neuron activity by adding the noise of it being mechanical. So it is just a different approach.
Yeah, or you could think of it that literally muscles are a signal amplifier. So you're actually measuring the signal post amplification, right?
Yeah, exactly. That's so you're filtering out. That's why it's meant when I said you filter out the noise. Like you only get the electrical activity that's responsible for movement, which is the actual activity you want.
Yeah. The good stuff.
The good stuff.
Good signal.
The good stuff. Okay, that makes sense.
I have a bunch of
Oh, there's the other one.
yeah.
Oh, I see.
Yeah, it's a little bit easier to read.
There is so much story of this. I mean, it's incredible. I can't tell if you sneeze or cough,
Yeah, and I
so I'm just
stopped.
gonna bless you, just in case.
Cough.
Close
No,
enough.
I'm still recovering from being sick.
That's fair then. That's fair.
I better let you go. Is that enough information? It's a crazy lot.
It is actually way more than enough. I will be honest. I will script it off stream because it's just easier for me to script. I mean, you can stay if you want. I never mind.
Yeah, I'll hop on later maybe, but I'm gonna cough a whole bunch. That way I don't have to worry about muting my microphone.
It's absolutely anytime you want. Please join. I beg you.
Sounds good.
Well, that was a successful Irish exit. Mika, do you have chicken eggs? I can check. What kinds of... You know what? Give me a second. Since Timon's muted, then I'm gonna go make myself coffee. And by that I mean...
I can unmute myself
Simon,
anytime, you
you
know.
fool! You thought I couldn't see from all the way in my kitchen. I saw you unmuted yourself. Consider yourself...
Well, what do you mean? I was like, I was literally talking to you. What do you mean?
All right, I'm back.
I wasn't being sneaky. I was talking to you.
I left. I don't know. I'm making
I
coffee.
that I
metal,
didn't
it will
unmute
always
myself
be
quick enough. I just told you that I can unmute myself anytime.
attached to a metal.
The only
It will
reason I was
always be
muted
attached
so I can
unless you give
save
it
a
some
little
energy
battery while not really talking.
to pull it away. So if we have our magnet attached, if we hit it with a
How am I supposed to do this? Manually.
ball, this ball will knock it off.
Though I
The same
still
thing-
can't read the YouTube chat because, yeah, for that I would have to load the
They're
stream.
all
and,
just really happy that you're back. Let's go, Timon's back. That's what Mark says.
Yeah, hi guys. Yeah, I'm back. That's not good because I'm only back because Turfta left. So there's that's sad. Like it's not that.
I agree, actually. I do. Tefta. It is. I like having Tefta here. We all have Tefta. Tefta has been just joining in on streams back when I had 400 subscribers. And now that I'm finally getting famous, Tefta just stops. Just only supporting me when I actually needed it. And now... ridiculous. I'm not joking. Tefta... Without Tefta, I don't know if I would have the channel today.
Yeah, Turfta's awesome.
Top 10 people. Top 10 people.
I don't understand a single word that they say, but still. still.
I mean, in this case, it's just more specific to the implementation. So I wouldn't say anything about OpenMasu is like scientifically difficult, as in requires some elaborate theory. I would say it's more about the amount of effort that was put into it. So it's not. So when it comes to OpenMasu, if you don't understand how it works, it's not because it's like hyper advanced physics theory. It's only because this is basically what Theft has been doing for years. So this is years of work boiled down into a single project. So obviously it would take a long time to understand how it works.
Yeah, I know it's like coding and programming isn't inherently that difficult. It's just a lot of knowledge.
Hold on,
Like
my coffee is...
there
Give me a second.
are stuff that are just a little knowledge, like a small amount of knowledge, but that knowledge is extremely difficult to gain because it's just a difficult topic, and there's sometimes just not that difficult, but just so much knowledge that it takes years to get through it all.
I mean, in this case, it is more about the... Just give me a second. I need coffee, I'm half asleep.
Yeah, relatable. I love coffee so much. The last morning or this morning or I don't know. The previous time that it was 10 a.m. in my region, I just brew just basically 2 cups of coffee and just put it in one big cup and just chugged it all.
Do you drink posh coffee or do you drink cheap coffee?
I drink some, like I brew it because it's way better than instant coffee, but I just brew it at some and then add some milk to turn into a latte, and I drink it. But yeah.
Make it... Are we still getting fridge cam on stream? Still? What do you mean still? When have we ever? No, damn it. Okay, this isn't meant to be quadratic. This is meant to be the opposite of quadratic. This has to be Bezier.
Sometimes I do drink posh coffee though. There are just those days when I just don't have the time to brew it at home, or I'm not even home, so I just buy something from Starbucks.
Starbucks? Jeez!
Starbucks is so nice.
Isn't Starbucks like ridiculously expensive?
I mean, it is. It's not. It is the best option. Best option because because I have my own cup, so that's around half a buck cheaper if you bring your own cup. Then I also don't drink milk. I drink plant-based substituents, and a lot of cafes charge extra for that, but Starbucks doesn't. And so so if I calculate with that extra charging, it's not that big of a difference. And my other options are that is easy to access, because like Starbucks is they're just one on my way to uni, and the other option could be the cafeteria of my uni, and the cafe there is somewhat cheaper, but just tastes disgusting, and Starbucks is tastes actually good, so it's the best option for me. After brewing myself at home, of course.
The most expensive coffee place near my area, and I live pretty close to the city, so that there should be pretty expensive. The most expensive I found had a cup of coffee for $7. And
$7,
that
$7.
is to me unreasonable. How much does a cup of coffee in Starbucks cost?
It's like $3.
That's a meal. That's a meal and a half.
Where the hell you get a meal for $3?
I cook at home.
Okay, fair.
Yeah, that's a
Okay.
meal and a half. I mean, $3. That is a lot. $3 is basically
To,
what?
cook.
What?
I cannot cook anything for $3.
Uh.
Euros.
Oh wait, hold on, Itty. Again, where do you live?
Netherlands.
You have your explanation right there. You're welcome. Now, would you have to? Minimum wage in the Netherlands is 3 times minimum wage in Poland. So, $3 for you is not $3 for me. But basically, I can. That's usually how much I spend on food a day, I would say. Frozen veggies, they cost. I just ate a pack before the stream, and they cost $2, and they are really, really good. $2 if they're not on a discount, that is.
Can I hit you with the tragic reality?
Yep.
I also cannot cook a meal from $3, and the minimum wage here is half of the Polish minimum wage.
Why can you not cook a meal for free? What?
Because food in Hungary is insanely expensive.
Trying to wrap my American mind around a lower minimum wage being good. Lower minimum wage isn't good. It just means that the country's poorer, basically. That's what lower minimum wage means. If your country, the lower it's a good indicator of basically how poor your country is. So, because the thing is, estimating how rich a country is really difficult, because that's a very, very vague thing. The concept of just a country being rich, it ain't exactly a business, right? It's not even how much money a country has, because it could just high really high taxes and everyone would have no money, the country would be rich. So it is a very hard thing to estimate, but minimum wage is a really, really good estimate, because it tells you basically how much, well, the minimum wage by itself is pretty self-explanatory, but also how much people can afford to pay for just like minimum effort. And right here you can see that in Europe, the more west you go, the higher the minimum wages get. And countries like the Netherlands, of course, like Switzerland. Wait, no, that's Luxembourg. Like, what the heck is Switzerland? Oh, yeah.
In Luxembourg, you need to realize
yeah,
that
doesn't
it's
have.
insanely high because there only lives one person or something.
But I've actually never heard anyone talk about Luxembourg. I honestly forget that it exists.
There's that video game where you are with the Czechs. I don't know the video, just the name of the video game, so I gotta explain that. You are with the Czechs, and it's probably the most historically accurate medieval video game. You are a blacksmith or soldier or whatever at the Czech army, and you have to defend your country from Zsigmond from Luxembourg, and that wasn't even that was some dude from Luxembourg who just decided to rule Hungary, and Hungary was like, all right, whatever, and so yeah. It's the most
625
historically accurate video game.
625 here in the States. Minimum wage per hour? Hold on. Minimum, because it depends on the state, doesn't it? Minimum wage in the US. What is the minimum wage in the US? Let's see. Minimum wages by state. Let's go with can I go with the highest and then the lowest? Why can you pick? This is doesn't matter. Okay, so the highest, I'm pretty certain it's gonna be California, right? It has to be. Never mind, Colombia. Color me surprised. District of Columbia has a higher minimum wage. All right, so 17 per hour. That's the highest in the US. which is quick maths, 17 times 8 times 5, that's 680 a week, times 4 weeks, 4 work weeks in a month. There are 1, 2, 3, 4 plus 3, so times 4.5 basically. That gives you $3,000. That's the highest minimum wage in the US, unless I did some maths incorrectly. But well, let's roll with it. And the lowest minimum wage is $7.25. I'm guessing that's a federal standard. Which one we could just divide this by 2, I think, which is 1,500. So Poland. Oh, but this is euro, right? Hold on. So dollar to euro, and that is 1,530. That's 14. That's close enough. Practically the same thing. It's something 25, close enough. But yeah, basically the higher the minimum wage, the more that's a good indicator of how wealthy a country is. And then right here you can see the different areas. The more west you go, the higher it gets. The more east you go, the lower it gets, and so on and so forth.
Yeah, and the lower the minimum wage, the less stuff, less anything costs in the country, because they just, if the people are poor in that country, they just cannot sell it for more expensive because no one would buy it.
Yeah, but I mean, it's
So
not
this is
it's
cheaper
not
here.
that simple either, because it also there are also exports. So it depends on the thing. Like food will be, but there are a lot of things which are just have constant prices along Europe, simply because it's exports imports. So if you're buying something from Germany, it is going to cost everywhere the same thing. And so that's why you still want the minimum wage to be as high as possible, simply because everything being cheap doesn't really matter if because then you're still losing on the export. Like everything is cheap internally, but no one actually benefits from it being cheap, because it's
Yeah.
because you don't earn as much, but the externally it's really bad. That won't stop landlords. I don't know. I haven't had that bad of an experience with landlords. So far, my landlords have all been pretty sweet. To be fair, I do usually like have look for places owned by people, not owned by like what's it called? Like the corporation kind of. I don't remember what it's called. And with people, you can usually just talk, and they're usually pretty chill. The employer could get away with paying less, they would, and we see that with the service workers, they have to rely on tips. And not always, Ninja. No, I mean, obviously, if an employee could get away with paying, that depends. I have worked a lot in the past with big businesses and small businesses, and I can tell you that with regards to big businesses, yes, they obviously, if they could pay less, they would, because I mean, but with small businesses, not really. There's usually usually bosses are friends with their employees when it comes to small businesses. I have heard some small business owners complain about the minimum wage, but I mean, it obviously is needed. But that's the annoying thing. The annoying thing is that very often you have regulation which affects big businesses and small businesses in the same way, which is quite dumb, because obviously the big businesses can handle the regulatory burden much easier, and small businesses will not do as much harm if they don't have that kind of regulation placed on them. But then you obviously need to define small and big businesses, so that's rough. Net income adjusted for living cost. What's that?
Or if lawyers and economics people weren't afraid of numbers and functions, you could just have, instead of these layers of small, medium, large, or stuff like that, you could just graph a function. For example, like with taxes, there are a lot of what you call them, like
Brackets.
yes, thank you. And like, why do you have them? Why can't you just graph a function, because then when you step from one bracket to another, it's just
Yeah, sometimes if you earn too much, sometimes when you don't earn a lot, if you earn a little bit too much, you're gonna lose all your benefits, which means that getting a raise will mean you're actually getting paid less.
yeah, like, and it would be all so much easier if the economics people weren't afraid of functions and could just write one function and one continuous function.
But yeah, so that's so TLDR. That's why if you click, you want to check how well a country is doing. One of the good things you can do is check its minimum wage. And you wouldn't believe it. Wow, Netherlands, that cool place where I want to live, has one of the highest in Europe. Crazy. It's almost as if places that are actually nice to live just are nice to live in. Piss. And that's why getting minimum, like the thing is, right now I'm trying to get minimum wage in Poland. That's what I'm trying to earn off YouTube. In Netherlands, it would take me years.
You can always
You
just add a
already are
side
minimum
job.
wage in Hungary. I'm sorry, I was talking over you. I'm sorry. Please say.
I just want to say you can always get a side job.
I guess I can, but then I would have to. Well, I don't think that would be beneficial to me though, because if I get a side job, I'll have to work less on YouTube, which means like my income wouldn't change by much. I would get a side job, but then I will gain some money from that and lose money from working on YouTube.
I work around 9 hours a week, or 6 to 9 hours a week, and I get 100 euros.
From what?
I mean,
What do you do?
Well, it's not per week. They did say per week paid. I mean per month.
Oh, 100 euros per month. Okay. No, then that 9 hours a week, then 100 euros. That's something. That's still high. Hold on. So that's like.
If I would combine it with YouTube,
Yeah, but that's a month. It's 1, 2, 3, 4. That's 36 hours a month for 100 euros.
Yes, that's right.
That's
I'm
not a
pretty
lot.
Sure,
And
also, I'm pretty sure if you got a side job, you would earn more than you do now, because a side job is a better pay by the hour than YouTube. And you could still work on YouTube because it's just 9 hours or something.
but I'll have to work less on YouTube.
Yeah, but you can still work, and it's yeah, you have to work a few less hours, but the side job is a better pay by the hour, so you would still earn more.
Okay, but with that logic, wouldn't it be better to just not do YouTube and get a full-time job,
Like,
which would pay even more?
no, because then you wouldn't do YouTube. But if you need a side job to support yourself and
As I mentioned, then I would do YouTube less. I mean,
yeah, it's not. I don't see your point. I mean, it's bad if you did YouTube less, but you could still do it without ending up on the street. And
yeah,
isn't that the
I can do
goal?
it without ending up on the street right now. I just need to make more videos until I earn the minimum wage.
All will knock it off, and the same thing
Yeah, but
happens for
if that
electric.
scheme failed, you
All will
could
knock it off.
get a side job and
the
still
same
not lose
Thing
the
happens for electron. We
progress
have
and still remain a YouTuber until you can you grow big enough that you can drop the side job.
No, I like my plan better. There we go. This.
I also like your plan better, but this is in case it fails.
As much as I do believe plan B is important, plan A is always better than plan B. And so if I have an option between setting up a plan B or ensuring that plan A will happen, I would rather ensure that plan A will happen.
Yeah, I never said you shouldn't do
Make
that.
it 10u10 positron and itty up volume wise. I can with Timon, but I cannot with itty. Itty is already max. That's why I actually turned down Timon to level them out, but then Timon was quiet.
It's not. Hmm. I can also not turn it up.
Sorry, you can what? I didn't.
That's how
hear.
that works. YouTube isn't a great source of income. I mean, eventually it is. Like, eventually it becomes a great source of income. It's just that it's tough to. YouTube isn't a safe source of income, I would say. It's gambling, basically, again. I'm slowly moving into my gambling phases, so you know. Moving it.
I think it's like if you study human sciences, it's like you work for years and you either get a good income or no income and end up being a cashier. What was this quiet? Is someone offended by me making fun of human sciences?
No, I was checking something.
All right, I got. Yeah. I'm sorry, I didn't hear it again because I was talking. Please
Don't worry.
say it again.
I was just saying I was paying attention.
Ah,
I'm trying to mesmer the chickens for my further farm.
Gambling, where do I sign? Should I go sleep at 2 a.m.? Yeah, you should. Unless you got something to do. Or unless you slept very recently. Unless, but at the same time, unless you have to be up tomorrow. But I don't want to. They don't. If you're only listen, if the only thing is don't want to, then don't. It's just simple. The only two reasons to actually have that kind of rigid sleep schedule is if you want to either if you either want like get up early in the morning because you have work or school or any of that kind of thing, or B, if you want to care about your mental health more. Because apparently, I know the brains don't like it when we're up all night. But if any other reason, I don't know. I wouldn't. I wouldn't, and I'm not. In fact.
my sleep schedule is all over the place. For example, I just slept 6 hours in the afternoon, then I woke up at midnight, and now I'm here.
Who cares about mental health? Well, you should. I care about my mental health. I may not be going for just, you know, standard typical, but I still want to be productive. And I can't be productive if someone recently on stream called my mindset toxic positivity. But, and I mean, I see your point, but it works. Or rather, I walk with it. That's all I care about.
Off, and the same thing happens for
You know,
Ellie.
the amount of YouTube videos you are able to make is not a direct indicator of mental health.
Depends how we define mental health.
I think we should ask a professional how they define it.
I don't care. That'll be their definition. I don't care for that. Healthy is relative. Why? Well, I didn't call it that. I said it could turn into that. Oh, we're way past that point. Toxic positivity isn't. I mean, I agree with that. It kind of is. The thing is, I could end up homeless, but I'm not, and so I can avoid that, and that motivates me. Desperation is a phenomenal motivator. Like, it's one thing if you walk because you know you should, right? Because you want to earn some money and so on. It's another thing when you walk because if you don't walk, you're gonna go homeless. And that is a boost.
We have our electron the metal. It gets hit
Good for
with a
you. When I feel stressed about something, I just avoid it at all cost.
Oh no, I pop off when it comes to stress. I am phenomenal.
Like, it's my biggest issue with uni is that it has consequences if I fail. If I had no consequences of failure, I would be thriving. But because of the consequences that that occur if I fail, I get insanely stressed about, and then my avoidance kicks in. Like if I yeah, I I I just yeah, it's real bad when the only reason I cannot sit down to study is because looking at the slides reminds me that if I don't learn it, then I will fail and really bad consequences. And then and then it stresses me out, and my brain just goes like, no, that's stress, that's bad, avoid that looking there, because if you don't look there you don't stress, and it's just so hard to fight that initial instinct of just avoiding bad stuff off, and that's just crazy.
I don't know, I
And
just...
that's
My fix to that was that when I enter that kind of thing where I start stressing over walking, and because of that I don't walk to avoid it, I just enter the manic breakdown, where I basically just sit down for a second, take a deep breath, turn on like batshit insane music. It's either like random noises remix, sometimes it's just white girl music, sometimes it's just I don't fucking know, even just musical music from kids movies and Canto or something, and I just go absolutely crazy and I crunch through a video in 21 hours. That's how I usually do it. For me it works.
Make it. Last one.
Yep.
yeah.
You too, YouTube chat. I'm asleep. Bye.
Bye.
Bye. Ja. Somebody call me and somebody think I'm sick. I might not reply very often. That's fine, Lemon, that's fine.
I get well soon.
Yep. Feel better. I'm not asking, that's a command. Anyway. Oh, that's my favorite thing in it's back when I was playing the finals some more. That's one of my I love that kind of mindset. When I was playing with lower ranked players, I'm pretty good at the game, and when I was playing with lower ranked players, as just when I was absolutely winning the game, was saying shit like, "You don't have my fucking permission to lose," was just powerful. One of my favorite clips from the finals was exactly that. Make it opinion on Canto. What is that? That sounds weird. I don't know if I like it. A B tier name at best.
Isn't that a set that the Cantor set in mathematics?
That's an alloy.
Or
It's an alloy.
it's an alloy. All right, that sounds interesting. I like alloys. Material science for
Is
the
it
win. Tell me about it.
iron, chrome, and aluminium? I think.
Ooh. All right, what does it do? What does it do? What does it do?
Hold on, I'm still figuring out with iron. I mean,
Just read the entire Wikipedia
give
page.
me a second. I'm first checking if I got the iron, aluminium, and Cr. It is chromium, iron, chlorium, and aluminium. Chromium and aluminium. Used for resistance, for heating.
Ooh.
And that's kind of it. So it's an electrical insulator that has good thermal conductivity. So heating, basically, like electric heaters.
And insulator, oh my god, that's so cool. Because it's metals and metal alloy and electrical insulator. Like, really? What?
That
How?
is the entire Wikipedia article. It's good for heating because it has high electrical resistance and low thermal resistance. And that is absolutely all there is to it. Just
What are
nothing
the
else.
percentages of what are the percentages?
Yeah, I don't think it says. There's a temperature
How are the-
coefficient, but there's nothing really about it. Oh no, wait, hold on. Iron chromium is 20-30% and aluminium is 4 to 7.5.
All right.
My brain's so
And
raw that I
this-
immediately thought of Cantle tilt. I may be done for.
What is the lattice structure?
Doesn't say.
Is there something like I can't Google it right now, so like,
The
isn't there
entire
something-
Wikipedia article is like 5 paragraphs. Or actually, no, that might be 5
sources-
sentences. And the
Any other
introduction.
sources?
Well, there is the PDF about it from 2005. Nope, 4.4 page not found. How about this one? Oh, it's only on Web Archive. There is from their own website.
Wait, this alloy has a website.
Yeah, because you have different producers. They Cantle is like the name of the company that makes this alloy. Yeah, and they just make like heating stuff from Cantle, I'm assuming.
That seems fun. I'm sorry, but you give me a metal alloy and I'm gonna love it. Like that's how I work.
I never got into the only I don't never really got how when it comes to alloys, they all seem so similar to me. Because I come from the like theoretical chemistry point of view. And in that case, the electron soup gets so average that in comparison to any other bonding structure, it has practically no characteristics. So, if you add, so the difference between benzene and hexane is massive, but like a difference between two different metals is very subtle. Because what you care about is still the bonding, the metallic bonding.
Yeah. Like you can cut some first period, not as first period, first group metals with a knife, and there's also metals that you can break no matter what. Like those are not the same. Like aluminum foil that you use to wrap your food, and I don't know, bolts in a bridge. They are both metals, but they are so different, and it's so beautiful how how many
I
different.
mean, they are
types.
different. They're just not that different. There are differences. It's just that if you compare it to like typical chemical differences, they're very subtle.
There is lithium that combusts as spontaneously when touches water, and there's gold that you cannot, you just cannot kick it as with any kind of.
Yeah, but I mean, lithium is an
almost
alkali metal.
oxide.
I was thinking about transition metals.
Yeah, you did not specify that.
Yeah, but I
But
mean, if you
still.
have alloys, I don't. Do you use alkali metal in alloys often?
I don't know.
Usually, because usually it is
I
transition.
think- I mean, I think magnesium is a widely used metal because like magnesium in itself is strong, but it breaks easily. So if you mix it with something that doesn't break so easily, but isn't that strong. Okay, I know it sounds weird that it's I say strong but breaks easily. When I say strong, I mean it doesn't bend. And if you want something that doesn't bend nor break, you can sometimes mix it with magnesium. But then there are other properties that are just trash. So yeah.
I think I just need to get more into higher abstract like sciences, more abstract sciences. Because that's probably the same reason why I don't why I didn't find organic chemistry all that interesting, because there just seemed to be a lot of like memorizing of different properties and not a lot of logic for these properties. So that's probably the reason. I just need to get into more abstract science.
I personally don't like organic chemistry that much, but I still see the logic behind it
There isn't.
because
There is no logic.
the mechanism of a
You have a
reaction,
case
like
by case
how
basis for almost all of them. The aromatic compounds can do practically well. I mean, even with fluorescence, the changing I feel like you need a sixth sense to figure out the how in what way a certain material is going to be fluorescent. You either need to simulate it or you need a sixth sense, or maybe drugs. That could also help, I suppose. Start learning about orbitals. Nothing makes sense. Get counted. You do realize that I've made two separate videos about that, right? Two separate ones, just about that. In case that you don't like the first one, I have a second one. In case one of them does not strike you fancy, there is this one. Right, if you look at it right here, you have the orbitals. There is this one, which once again, if you hover over it, you have the orbitals.
also if you're asking why they have the shape they have, because they have very funky shapes, and that is you use the spherical functions of some dude with weird name, and to get those functions you need such high level mathematics that they don't even teach at university bachelors. So I don't think that one YouTube video can explain the exact reasoning behind the exact shapes.
They said they start learning about orbitals and cooked. I'm assuming they're learning it like from a chemistry point of view, not quantum mechanics.
Yeah, no, but when I did chemistry, I was so annoyed that they just gave us that, yeah, these are the shapes, and I asked why, and they said because of reasons. And then I started quantum mechanics, and I realized
I
that,
mean, no, the
all
shapes
right,
are pretty
we are
obvious. It's because the principle just increases the size of the wave, basically. Like, increases the domain of the wave, let's call it. The azimuth is the... Oh, I had an equation for the azimuth. For one of my videos, I actually found it. There was an equation for how different quantum numbers modify the wave function. I would need to look for it, but it's not as bad. It's not that complex.
like S and P are easy to see, but when you get those rings and everything, is like, I don't know, they just told us at quantum mechanics that, yeah, the math
So
here
you
is
mean
way
the
more
magnetic
complex.
moment? Is that the one that confuses you?
Uh,
Wait, hold on. Azimuth and magnetic? I think it's magnetic, the third one. Magnetic, yeah. So magnetic is the one that confuses you.
uh, it's not that it confuses me, I'm just aware that the mathematics behind the exact shape is right now still outside my reach.
I don't think so. I think you're undervaluing yourself in this case.
Have you seen the...
You're either underestimating your abilities or overestimating the complexity of it. Because this is magnetic is often noted with the x's, y's, and z's because I always call it an orientation because that really is what it is. Except it's not it's an orientation in the abstract sense. So when you have the wave function, if I do remember correctly, the principal scales it, the azimuthal it modified the complexity. I think of an exponential, but it's been months since I actually looked at that last time. And the magnetic was basically like you taking the wave function at different orientations. If you want to know,
I know that's not what I'm talking about. I know the basics. I feel like you either don't understand my question or just Dunning-Krugering it.
I don't know what your question is.
So you know how as the complexity increases, those are there are just fancy shapes, right?
Yes.
But the exact reason of the fancy shape, like the exact function that describes said shape, is very hard to. It's a very high level mathematics to get the exact function.
But wait, do you want to memorize that function? What do you want?
No. I can look that function up anytime.
But like, what do you?
Like, there's that function that and someone calculated that function at some point, and you can look it up from tables and everything. But to know exactly why they are the exact shape like that, you have to understand how that function is calculated. But to calculate it in an elementary basis, you need such high-level mathematics that I did not learn yet. And I just, at this point, I have to accept that some other person did the calculations that this is the function they got. And it's just a bunch of sines and cosines and exponentials and square roots of fractions, and they are pretty big functions, especially with larger quantum numbers. Larger azimuthal quantum numbers, to be specific.
Hold on.
I'm gonna try to.
I just realized you're
look
not on
up
stream, so you can't actually. Well, if I ask you if this is what you are talking about, then you won't be able to tell me. But you basically mean this, right? I can screenshot and send it to you.
Alright.
Because this is what I think you meant. I know if I'm misunderstanding. This is
Um. Um.
what's time on about? Obtus.
I'm not sure. I'll just.
This is the radial
look it up.
stands for the radial probability function. So probability of finding an electron in any place, based on the n and l, so the principal and azimuthal quantum number.
Okay, but how do you get these equations?
Yeah, that's why I'm
the
asking
kicker,
if this is what you mean. You know, getting these.
This is not actually what I mean. I know the previous step, I know what equations you get these from, but I don't know how to get those equations, and that's what I'm asking.
I remember there was for each one there was a function that generates the shape.
I know, but how do you get that function?
I told you the last time I actually seen that function was months ago.
Like,
I don't remember where I had there was a paper. Example. No, no, wait, that is just the wave function. Radial probability distribution
Yeah,
function,
but
it is just wave function. Yeah, makes sense because radial. So radial
yeah,
probability.
okay.
So it's basically
Yes.
what you're asking is for is the wave function of an electron.
Yes, but to get the wave function of an electron in a high azimuthal quantum number, you need some really funky mathematics that I just can't.
I told you, believe in yourself.
Like I have like I've learned about this stuff, and that is why it's not that I don't believe in myself. I know that I will learn this eventually. I'm just aware that for now it is out of my reach because it's um
Motto to eat by type fast, eat ass. Great. I would believe in myself if there were peer-reviewed studies supporting this point of view. Quantum number. Okay, so that's the spin. Rejection energy. I mean, the thing is, the quantum numbers in this case. That's all the quantum numbers, which means they would be, if I'm not mistaken, if you want to actually get that, you get that based on the operators, because they are eigenstates. So you would need to get the operators of the wave function, and then basically from solving the eigenstates of that, you get back the quantum numbers. So you could just do it backwards.
yes, I know that. I know that, but there's just in that entire process there's just one step missing where they just when you get the quantum numbers, you then you have these um you have these quantum numbers, and you just what we did at quantum mechanics is that they listed us a bunch of functions, and we just had to figure out what to substitute in, because to get those functions you need such high level mathematics that we did not learn yet.
Okay, so this way I have allowed energies. That makes sense. I already have it open, but second doesn't help. Really contribution. Radius. Nucleus. There we have it. Yeah, I mean, it is just. Yeah, people younger than me exist. How fascinating.
um
We ain't seen nothing yet. Wait,
I think I found them. Hell yeah, Yeah, okay, I found them. I think I'll first just send you a screenshot so you know what to look for in the wiki page.
I could just go look through my files and open up the PDF because I'm pretty certain I downloaded it, but it would take a fair bit.
No, just to go to this wiki page and the first chapter after the introduction part. It's the complex spherical harmonics, and you can say a bunch of equations, and they are all very, very, very big, and especially when the azimuthal quantum number just uh, gets big, and you cannot just simply pull this out of nowhere. You need extremely high level mathematics to get these functions.
Mm, the high level mathematics, that's pretty rough because I mean, I don't know if you can see that, but there is like a very, very clear algorithmic feel to it. Like if you move past the original constants, it is just e to the and then the power you just add one each time, and then the sine power you just you subtract you have 10 minus absolute value, and then the cosine is once again also algorithmic. There's an
Right.
algorithmic thing to it. It's not like it's not an
Let's
insane method.
All right, let's say I figure out the algorithm and I can just write any of this from the top of my head. Still, just because I figure out the algorithm, like, doesn't mean that I know the um, mathematics behind it.
I mean, yeah, but that's why I
Like,
struggle understanding. Like, what do you mean by mathematics behind it? What kind
like
exactly?
I can look at it and see a pattern, but I still don't know why that pattern exists.
Well, I
I
mean,
know from first hand that if you see a pattern, you gotta better know why it exists and don't just believe it that it's a fucking pattern. So yeah,
this is physics. In this case, it if you see in this case, you don't always have to know why something exists. As the
but
standard model being the best example. But I
yeah,
mean,
but
the
this
obvious
one
answer would
has
be that it just fits. The non-obvious answer is that there is. As I mentioned, I did have the PDF. Wait, isn't that one MIT one? That might be it. I think it was from MIT, so I might have just actually got it. There is a. I had a PDF in which you just had the um the function creating wave functions based on the numbers, and the only thing that wasn't explained there is that there was a scalar that was just different on case by case basis. But I mean, that's just the scale. I don't think you would be interested in the scalar. That's why I'm asking what kind of mathematics.
you can see that you may see the algorithm of how these functions get generated, but you don't see why that algorithm is there, and there is a long and very big mathematics behind how to generate these functions, and that is just pure mathematics, has nothing to do with quantum mechanics. And but to see why these functions work, you need to understand those that mathematics behind it to say that
I mean, yeah, that's fair.
to
It's
see
just I think like you're overestimating the difficulty of them.
I mean, I don't think so, because I'm aware of I'm aware of university level mathematics that is required to physics. Believe me, I'm aware how difficult it is.
Well, I just found you the table of circle harmonics you sent. This is a bit more detailed breakdown, although the y is still questionable there. I guess it's frequent number because it follows a value n can be fixed. The wave function takes from this, where a is the normalization constant, n is equal to n minus. So capital N is just the two quantum numbers of polynomial degree, and that makes sense. Wave function value n can be read as exponential factor. The value of L can be read from the radial prefactor or from the spherical harmonics. The value of M can be read from the spherical harmonics with the ground state, and normalized wave function is. So right here it. Okay, yeah, so it generates the.
But what you sent me is the wave function, and what I'm talking about is the y at the end, the letter y. That's the spherical harmonics is the letter y, and what I don't understand is how you get those spherical harmonics, and the reason why I don't understand it because we did not learn that yet in mathematics. We just don't have the mathematical background to get that.
So you think that the spherical harmonics is too difficult?
Yes.
Have you tried getting into it?
I'm pretty sure if I got into it, I could eventually understand it. I'm also sure that I would probably have to get into it if I go to masters. I'm just not sure. Even though I was super interested in the why exactly do we get these functions when I was in ninth grade. Now that I see how difficult the mathematics behind it gets, and I have less time to get into random stuff, not as less time, less energy rather, because the time isn't really my issue. My issue is that I have a limited capacity of hours I can learn a day. So yeah, I think I'm just cool with waiting a few more years until I learn it in university. Of course, in high school when everything was easy and I could ace every test with my hands behind my back. It was I got any question I had. I just went after it, asked my teachers, asked Google, whatever. But now that I struggle with every single subject, I just feel like it's better to not get sidetracked and just accept that some of the material is still out of my reach and just focus on what I
Found the equation.
need to learn.
You want me to send you the paper? It's really
Sure.
short. It's only 14 pages.
I think I can, even if I don't understand everything, I just scroll through it. So because I love quantum mechanics, it's so cool.
It's not too bad. It's actually pretty good when it comes to functional complete by this way differential angle. Yeah, so this gives you the thing. It is only 14 pages.
All right, I'll scroll through it.
And actually, the second one is the second chapter is the spherical harmonics. After that, it just expands on the like more of an application of spherical harmonics. So you only care about the second chapter, which is page and a half. And over there you have the
Alright.
equation, which it gives you.
Uh,
When it comes to the source of spherical harmonics, I don't know how much you should care about that, simply because, like, I don't think you'll find a reason that will be more compelling than just because because it's basically like it's either going to be symmetry or something like that. It's because it's spherical. It's because we want it's radial except in 3 dimensions.
yeah, I know. That's why I'm not really bugged by not understanding it. I'm okay with yeah, all right. I'll learn about this whenever, whatever. Like I'm not saying it bugs me. I just told you that this is a part that I don't yet understand. That's
I
all
mean,
I
I
said.
know, but all I'm saying is that I think you're just underselling yourself, selling yourself short. My whole brand is on the fact that science isn't as difficult that people make it out to be. Like, remember how you mentioned with quantum mechanics, how I said it's simple? I mean, it is. It is simple. It's not difficult to understand quantum mechanics. And so I feel like you should first just give it a solid try before thinking it was difficult.
I, I did give a solid try to quantum mechanics, and I loved it. I love quantum mechanics, and we have a lot of way more difficult subjects than
I
quantum
meant
mechanics. Like,
spherical harmonics when I said solid try.
uh,
I mean give them a
uh,
try. God, I hate
I'll give
Elon.
them a try when I have to. Give them a try when I get there in my studies.
God, I hate Elon. I'm not prepared for him to be in my government in 3 days. Sucks to suck. At the same time, though, I shouldn't be cheering too much. Elon Musk is also getting into European politics now, so that's great. Can someone give me motivation to keep working on my project? I really want to deal with electronics. Yeah, what's the project?
Now that we're here, I just pretend that you're talking to me and you're giving me motivation as well, because I don't really have that. 2.5 years of stress and being told that you're not good enough and you'll never make it in science can
It gets hit with a
get to a
photon,
person.
and it's not
Jeez.
off.
But that's precisely my point. I feel like you are really... Because here's the thing. I also want to tie it something with what Stamp said. Because Stamp said, I really think people are just scared of science. That's not quite the case. Scientists are really good at doing science, but they're really awful at communicating it. And because of that, really
Yeah.
often when you look something up, you either have sources which you don't trust or sources which you can't understand. These are the only two. And because of that,
Yeah.
things which have a simple underlying explanation end up being considered really difficult. Quantum mechanics being a great example of them. Literally right now, I'm making a video about that. I do believe that that circle harmonics will also be there. I think they also will have a simple explanation that is not covered. The Fourier transform, covered in the past. The organic chemistry ones don't get quite of a bad rep. But equilibrium constant, another good one. Really often considered extremely difficult by people who don't do chemistry, simply because it's not conveyed correctly, and so on and so forth. And when it comes to me, so far, the absolute undeniable majority of things I have seen have been just thought of as difficult, not because they are difficult, only because, well, scientists were just bad at communicating what they are. I'm 3D printing a nerve gun. Only a nerve gun? You could have done. You could go further.
Okay, so what's the problem then? Well, you see, when it comes to our electrons, they need a certain amount of energy to get knocked off. So just like with our magnet, if it gets hit with a tiny ball going off,
I'm just
so
I'm just so mad that that either you're not older or I'm not younger or something, because if you had just a few more years YouTube behind you when I got to uni, it would be so much easier. Like, just if I could have done classical mechanics with understanding the fucking Fourier transform, but no, you you were a year late with your how math becomes difficult, so it's your fault that I struggled with. You could have saved me the struggles if you just do it a year before.
The year before, I was just getting into advanced sciences.
Yeah, I know.
I've got Revolver to clarify in the Minecraft type of statement.
I mean, your videos are an insane oversimplification of what I learned at uni, but it's...
What's really funny is that most, what I'm catching myself more and more recently is that they are not an actual oversimplification. Like, the Fourier transform was simplified, but it wasn't an oversimplification. It was just only with real numbers. Like, complex numbers in that case do not change how it works.
Yeah, it's like...
Or me calling something electron density, that's not really an oversimplification. Or how many electrons are there? You can think of it in this way in quantum mechanics, of just electron density being as how many electrons you have in a given spot.
Yeah, it's probability density, but still, like... Yeah, the thing is that it's missing like years of mathematics behind it, and it's completely fair. You can't just assume that your audience knows high level mathematics, but it's because it's missing. It's that material, but without the mathematics, it gives such good intuition that my teachers could never.
Bye lemon,
Yeah.
bye, see ya.
Bye, Lemon. Like, so yeah, no. I'm just annoyed that your videos are so easy to understand and so useful.
I always thought of my videos as not good enough until I started actually reading like lecture notes and so on. Like, this is how they teach stuff with lectures. And then people wonder why no one understands anything. Make it, who is Tyler? Tyler? Just Tyler. Yeah, I don't know what description to give you. Philosophizer. That's kind of it. Joins in on stream now and then, pretends that philosophy is, you know, viable, leaves. Usually how it goes.
That's Tydon who.
That's Tydon. Ah, sorry. Yeah, Tydon. Wait, Tyler? You're asking about Discord Tyler then?
Isn't that just a random high school kid from the Discord server?
Yeah, someone who's Tyler is basically someone who really likes chemistry, or actually really likes asking Flame chemistry questions, to be more exact. I dig that.
So just like with our magnet, if it gets hit with a tiny ball going slowly, it won't budge. The ball needs to pack enough.
I remember that I didn't understand something from several things from the whatever the explanation my material science teacher gave me, just a real trash explanation, and I just accidentally clicked on the chemistry channel, and it happened 2 times, and it was just Flame explained it, just happened to explain it in 1 sentence, and like, oh my god, that helps me understand the entire chapter.
Yeah, I mean, yeah, that's what I'm saying. Most things in science do go this way, where they are considered more difficult than than they actually are. I know he was mentioning the Skip series. Tyler, which, oh my goodness, no.
What?
Not that Tyler, jeez, not a lot of Tylers over the years. I think it was mentioned the Skip series because I think it was someone who watched the channel, if I'm not mistaken. The thing is, back then I had 300 subscribers, so anyone who commented in any way or joined in the Discord server would get just I would just thank them personally in the video. What is a science concept that is as difficult to understand as it seems? That's a good question. Usually, it's not really as difficult to understand as it seems, only it seems easy. That's usually how they get you. And in that case, I would say it would be... Okay, one which is counterintuitive is relativity. Simply because... But that's actually a different fault. The problem with relativity is that people just don't want to believe it can make sense. So that's one. As difficult to understand as it seems, I would say Higgs is not a good example. Higgs and electroweak interaction, they're both as difficult as they seem, simply because the way they combine, or the reason why electromagnetism is a single fundamental interaction is another good one. Basically, when you get into really advanced theories, so you don't normally learn about the Higgs field, you don't normally learn about why electromagnetism is a single interaction, or about the electroweak interaction, and the reason why is precisely because they are so advanced. So usually, the only times when things are as difficult as they seem, those things are so advanced that unless you've already finished the university, you will not like wonder about them. The thing is, if you finish in university on certain topic and you have something you still don't understand, that's how you know it is as difficult as it seems. I guess in that case, electroweak would be... Remco gets it. So I don't know if electroweak would even be there. But...
That just sounded like Remco gets it, so it mustn't be that hard.
I mean, no, I mean, my definition just doesn't hold because, you know, that's why I said it. But, oh, why there are 6 quarks, that's a good one. Or just, you know, why there are 3, what was the name for it? 3 generations, exactly. That's another good one. I mean, Higgs is a great example because almost no one gets how the Higgs works. Or why isn't it even theorized? What else is there? What else is there? I think that's kind of weak interaction. If you can predict how, if you have a certain elementary particle, if you can predict how weak interaction affects it, I would be really impressed. Because weak interaction is really confusing.
I would like to add a little bit more relatable for the chat that they can relate more. That I think it is part
for
of
the
it.
chat,
I think
see, you're no longer a peasant. It's for the chat, for them.
No, I just meant that most people here are high school students. So they probably can't relate to how difficult the highest level of theory and physics are. So maybe I think...
I don't think anyone here can relate to that.
Yeah, but they can relate it. Like, okay, I can't relate either, but they can relate even less because...
I don't think it matters. I mean, okay, anyone here, raise a hand if you know why electromagnetism combines with the weak interaction at high energy. No takers? Oh, really? It doesn't really matter if you're a high school student or a university student. You have no clue whatsoever.
Yeah, but if you're a university student, at least you have a clue of how basic physics, how difficult basic physics is. And I'm not saying it's very difficult or not difficult, or I'm not saying this. I'm just, you get a sense of the difficulty and complexity, whatever that may be, and it's so you have more data points to
I don't know if Timon just didn't finish sentence or if you just got cut. I think it was the second one. Okay. Well, fun while it lasted, I suppose. Timon will miss you. We will certainly miss you. I think Timon's internet may have died. Well, happens. Rip Timon, so young. Happened, Big Bang happened. Could have been one big mega force. It's not quite. It's no, wait, hold on. This doesn't seem right. This one? Just delete all of these. This one. Oh yeah, I guess what am I doing? We can just switch back to the...
It's like with our magnet, if it gets hit with a tiny ball off.
Alright.
So just like with our magnet, if it gets hit with a tiny ball going slowly.
And there we go, and there we go. Already past 4 minutes, that's pretty good. Rest in poor connection. Yeah, it's tragic, such a young age.
Slowly, it won't budge. The ball needs to...
Right here, there we go. And... Wait, no, that's absolutely and completely wrong. This is what I meant. There we have it. That should be enough.
Ball going slowly, it won't budge. The ball needs to pack enough punch to actually knock it off. And the same thing happens... Pack enough punch to actually knock it off. And the same thing happens for our electron.
Okay, and right here we just needed to go back when both of these are gone. Okay, whoops. There we are. Well then, everyone, how are you all doing? 7:30. Good. Glad to hear. Glad to hear. Why is there a mysterious... There's some weird sounds going on in my apartment. I don't know what's happening.
Our light needs to have enough energy to knock the electron off. And once it does, the kinetic energy of the electron rises with...
Okay, I hope this animation will clear it up enough for it to be actually worth something. Yep. Isn't it fun that I'm probably going to finish this video today? 2 days after the last one was finished. Doing angle exercises. I'm going through the geometry in the beginning and have finished with lines. That's good. Good stuff. Well then, I think I'm gonna go for now, simply because I need to focus a bit. We are putting out a lot of videos right now. Yeah, because why not, am I right? Just, why not? New video every 3 days, everyone. Nah, it's fine. It's fine. I'll go sleep now, get some more guys and make it fun, continue whatever I do right now. Alright, Tiafanik, good night. Good night to you all, in fact. Good night to you all. And I'm gonna go and finish the video. So, for now, that'll be it. Thank you everyone so much for watching, and have a great day. Bye.